Right, good morning everyone. On behalf of the organising team, it is my pleasure to welcome you to the first ever Oxfordshire Future Manufacturing Roadshow. It's a collaboration between colleagues and friends at the Manufacturing Technology Centre, the Satellite Applications Catapult and the Harwell Science and Innovation Campus. I'm Chris Dunkley, the Deputy Director for the Oxfordshire Cluster at the MTC, and before we start, it is my duty to do a little bit of housekeeping. So for those people here in person, we do want to make sure you are as comfortable as possible, and we have, as you can see, limited the numbers. So if you feel comfortable wearing masks, particularly around the exhibits, then please do so. The fire exits are very well marked. They're through the doors here, and the assembly point is in the car park. No fire drills are planned, and the toilets are on the ground floor to the right here at the end of the building. We will be having a break at around about 11 o'clock. We have a roaming mic for the Q&A sessions. Can I ask, even if you've got a really loud voice, if you can use it, because we are streaming this and we've got quite a lot of people online. And for those that are online, on the Hop-In platform, you'll be able to see where you can ask questions. If in the room you can put your mobiles on silent or vibrate, and if you can put yourself in fully engaged mode, there is some good stuff coming. So, over with the housekeeping. We read daily and experience about the truly groundbreaking advances and the technologies coming out of the Oxfordshire clusters, particularly between the space, energy and the health tech clusters, and also across the Oxford to Cambridge arc. We want to ensure that they can be scaled up and produced in the most effective way, fully aware of the challenges ahead and connected to the right people and supply chains from across the UK. Today, we are introducing you to some of the key advances in manufacturing technologies so that we can start a conversation around why and how they can be adopted, some of the ways to overcome the hurdles and the barriers that will undoubtedly be faced, and ensuring that we have the talent required to do so. So, please spend some time with us this morning and over lunch exploring the technology demonstrators, talking to the research engineers, and interacting with the expert panel discussions on automation, digital manufacturing and future skills requirements. Those panels feature those that can support adoption, and those with the experience and the battle scars of implementation within their own businesses. So, just to give you a little bit of heads up in terms of what's coming up. When I've finished, I'm going to ask the organising participants to just make some opening remarks. We then have a digital panel chaired by Shaq. We will then have a break and then a panel on automation adoption, which is chaired by Mike Wilson from the MTC. Probably the highlight for me is that we'll be hearing the life stories of a couple of the Oxfordshire apprentices. Really looking forward to that session. And then the last part will be around looking at future skills, and Joanna Hart from STSC will be chairing that session. So I'm delighted to ask Claire Pickin, who's the Managing Director at the Manufacturing Technology Centre Operations, to say a few words about the MTC and introduce you to what we do. So, Claire.
So, thanks very much. As Chris says, I'm Claire Pickin, MD for MTC Operations. I'm really excited, actually, to be here today. I'm a proud Oxonian, born, bred and returned, having moved around a bit before. And it's particularly special to be involved in something in my neck of the woods. So firstly, I'd like to share a short video, by way of introduction, really, to the Manufacturing Technology Centre. I'm pressing the button and crossing my fingers. I should have pressed the button earlier.
We are the MTC, one of the most exciting initiatives in manufacturing research and development for the last half a century. We're part of the High-Value Manufacturing Catapult with a vision to inspire great British manufacturing on the global stage. We're We're passionate about developing tomorrow's industrial solutions today. We're bridging the valley of death between academia and industry by taking the best research and ideas from our universities and turning them into commercial reality. We understand the challenges of investing in the development of new products and processes, and we are here to help reduce that risk. We bring world-leading research and innovations to the UK manufacturing sector, revolutionising how things are made and delivering real-life solutions. We're playing a leading role in the digitisation of manufacturing in the UK and are home to the National Centre for Additive Manufacturing. Through our groundbreaking technologies, we help companies implement new ways of thinking to transform traditional manufacturing practices. And we provide a unique environment to prove their viability in the workplace. Our approach is simple. We take your business challenge, then we combine a team of skilled engineers with world-leading tools and technologies to create an end-to-end solution for you. We have a flexible approach, helping companies in all sectors and of all sizes, from SMEs to global enterprises. Some of the UK's leading global companies are already benefiting from working with us. We're also developing the engineers of the future, providing young people with a first step on the path towards a world-class engineering career through our apprenticeship programme. Whether you want to improve productivity, develop new market opportunities, or implement new skills and technologies, you should be talking to us. We are the MTC. We're inspiring Great British manufacturing.
So, as you can see, at the MTC we cover many different technologies and operate across a wide range of sectors. Across all of these, though, there are various themes that have been emerging recently. Skills shortages and the requirement for additional training, but not just additional relevant training that makes us fit for current and also the future. Capacity constraints. So there is a well-publicised shortage of available labour and the productivity challenge. And we keep hearing stories about problems within supply chain and getting things. And actually, to be honest with you, yesterday I did start to panic about that because there's some issue about wine and beer potentially being a shortage for Christmas. So I don't agree with panic buying, but I'm going to on this particular occasion. And the journey to net zero, with the requirements to reduce consumption and waste, and the adoption of green technology. 2050 is coming up really very quickly, and we have to start somewhere. We have to start now. We need to work on it straight away, because it will come to us. So at the MTC, we are very familiar with the valley of death, as just described there, between the universities and industry. That's actually where we work. But there is also another valley of death, which is relating to the application of technologies, automation and digitisation. There is such an opportunity and need to transfer innovation from one sector to another. And that will actually accelerate the transformation. But this requires an understanding that there is another way and that change is actually required. Now, some sectors embrace that change and others are struggling to grasp it. The reality is that it is coming. It will happen, so we need to be in a position to encourage and support it. We work very closely with some big companies at MTC, but it's becoming increasingly obvious that the route to unlocking the potential is through the supply chain, including many SMEs. And as such, there's a significant focus on enabling their development. So part of this could be providing accessible technology. It's not just about the hardware, it's about supporting the journey and decision-making process. An example, we have a great tool about the roadmap for automation that we've developed within MTC. There's also business case support. So to demo, it is or is not the right solution for a business. Demand pipeline aggregation. So small companies need the confidence to make investments. Technology try before you buy. It's the physical development, demonstration of a development. and I designed for manufacturing automation. I maybe should have started with this one, actually. So it's not about automating what you've got now. It's actually going right back to first principles and designing something such that it can be, and that technology can be adopted. The list really does go on, and so do I on occasions when I get excited about a subject, so I will leave it at that, but that's an example of. So our aim within MTC is to develop a national capability that can provide a local impact. In addition to Oxford and our main facility in Coventry, we also have a site in Liverpool where we've developed our digital manufacturing accelerator, and that is a tool for stimulating innovative ideas in the digital world in support of manufacturing development. I think this is a good model and one that absolutely makes sense for Oxfordshire. It's something that's been developed locally to then become a national asset. So we've got some great panel discussions for you to look forward to, and the opportunity to have a look around the exhibition. Some of you might have done so already, but definitely spend some time in there. So I beg of you all to make the most of it, enjoy what we've got today. And for me, this roadshow is very much about the chance to start that conversation around the future that is technology and manufacturing, and the stages to greater adoption and further development. So thank you for your time. I'd like to pass on to Paul.
Thank you, Claire. And thank you, Chris, as well, for organising this. It's really great to have the opportunity to welcome people back to Harwell, to actually get together and do some innovation. It's what catapults are here to do, to help bring people together. And it's really great that we're working with MTC on this new initiative to bring the focus of manufacturing to the Oxford cluster. So I'm Paul Fevre, I'm Chief Technology Officer at the Satellite Applications Catapult, and I'm going to give a little bit of a space focus to the conversation today, of course. I've been working in the space sector for a few decades. I won't go further than that. But it's really interesting that right now the space sector is in the ascendancy again. You just have to look across the globe at the recognition of the value that space provides to economies, to supporting infrastructure and its delivery of services to communities and to citizens. And even in the UK, we're actually increasingly recognising that and reorganising in government to make sure that we can maintain that position as a space nation. The catapult itself, it's an applications catapult. You can see, what does that mean? That means we're here principally to support the exploitation of satellite services around the globe, but helping UK industry work with the latest innovators to actually bring new services to communities. That's about 80% of what we do. And it means that what we end up is we get engaging with agriculture, with transport experts, with mining sector, with the healthcare sector, for instance, understanding how the challenges that they face today could possibly be solved through using satellites. And that's really what we're established. But as a research and technology organisation, we also look into the future. And one of the critical things, about 20% of the work we do, is to envision new concepts, disruptive concepts, and help bring people together to see those be realised. And that's part of the purpose of the catapult. It's not only the infrastructure that we've got here in Harwell, but we've got other sites as well, and we support clusters around the UK. So just over on the left is the Westcott facility, which is in Aylesbury, near Aylesbury. And that's where we're doing some of the manufacturing capabilities we're exploring and experimenting, supported by the MTC in terms of things like additive manufacturing. So we're creating these spaces where people can work. I think really what's fascinating, though, as I mentioned at the start, is the changes that are taking place in the space sector. And 10 years ago, we started to realise that actually there's going to be a significant change caused by the reduction in the cost of putting infrastructure into space. That is being manifest now with constellations of satellites being deployed, proliferating assets in space to provide the capability that is needed by society. And that's witnessed in things like the OneWeb system, the Starlink system. But actually that infrastructure, that increased infrastructure in space, is changing the way that we deliver the other services that we'll be familiar with, such as navigation services, broadcast services, but also Earth observation. It effectively creates the fabric in which we'll be able to exchange information and bring it to the hands of users in real time in a way that we've never been able to do before. And that is enabled by the digital transformation of systems. But the critical thing here is, in order to achieve the economies of scale, we need to manufacture using everything and all the tools that are available, the Industry 4.0 paradigm. And that's not just for the infrastructure in space, it's for the exploitation angle. So for every asset that goes into space, every satellite that's launched, there's probably something in the order of between 1,000 and 1 million devices that are deployed and put into the field. And that is a critical area where, as we scale up the space infrastructure, we need to scale up the production of capability and putting it into the hands of users so they can access the services. And that's key to potential the transformation that's taking place in automation, in things like the transport sector, in the way that the renewable energy sector is going to need to operate the systems, it's no longer point-based generation, it's wide area generation of electricity by scavenging energy from the environment. That changes the nature of the assets and the services and the way that they're used. So we're seeing that now. By 2030, the capabilities will be almost indistinguishable from those which you're obtaining from terrestrial systems, which means that they will be used even more and everywhere. But really what's fascinating, that increased infrastructure in space, thousands and thousands of satellites, cannot be managed and maintained in the same way that we have historically done that. These assets will need to be managed in an automated fashion. And furthermore, there's a significant case for upgrading them, for maintaining them, for providing new capabilities on existing infrastructure. And that brings up the opportunity for doing space-based manufacturing, for instance, in our operations. So by 2030, there'll be so much automated infrastructure in space and the production of upgrade of infrastructure, we can envision a different economy beyond 2030, and we're already working towards this. Whereas in addition to the proliferation, we will see massification, large structures. Only yesterday, my colleague Sam Adam was on the BBC talking about space-based solar power, creating solar power stations in space because there's always daylight up there, and beaming the energy down and driving the hydrogen economy. That's just one instance. What we can expect is, for instance, space-based tourism, but also manufacturing of things that are very hard to manufacture on a terrestrial domain, things that need a close to zero-G environment. So the future of the space sector is intrinsically woven in the future of the manufacturing sector, which gives me great pleasure, therefore, to welcome this first Oxford the first of these opportunities to bring the manufacturing to the Oxford Space Cluster. So I'm going to hand over now to Barbara, and she's going to tell you a little bit more about Harwell and all the other exciting things that are going on in the cluster. So welcome from me. I hope you have a great day, and let's work the future together. Thank you.
Thank you, Chris, first of all, for inviting me here, and thank you to Claire and Paul for a great set of presentations and really setting the scene of why are we here in Harwell today. It's great to have the first roadshow of manufacturing here on this campus. So I'm Barbara Ghinelli. I'm responsible for the development of our innovation clusters here at Harwell, but also in our other campus in the Northwest in Daresbury. My role also involves working very closely with our JV partners here at Harwell to develop this campus. And that's what I'm going to talk to you about a little bit more in detail today. So, I don't know whether many of you have had the opportunity to go around this campus and see the amazing set of capabilities, infrastructure, large science facilities, the many companies that we have here, more than 200 companies. We also have many universities working on campus. So this campus has attracted about £3 billion of investment already. And therefore, what we are here to do is to make sure that that investment is put into the best of possible benefit for the economy and society by exploiting it and by working together. So this campus is very large and has been developed, as I said, by our joint venture partners. So there are places which are an agglomeration of capabilities and facilities, followed by areas which are occupied by our businesses. And there are further developments coming in this. We've got research institutes like the Rosalind Franklin Institute. We've got the Vaccine Manufacturing Innovation Center here. We've got space capabilities which are built around this cluster, the space cluster, like the new National Satellite Test Facility. So I could go on and on and on in the list of things that are actually hosted on this campus. But one of the things that really is the engine of growth of this campus is the development of our clusters. And these clusters are really very much about collaboration, enabling collaboration. Claire talked about what do we do actually, what can we do to stimulate that cross-sectorial collaboration, the use of different technologies across different sectors. So getting people outside their boxes, thinking much more widely about what do we, how can we actually exploit technologies developed in the space sector. And Paul described and gave some very good examples there into, for example, the energy sector or in the health sector. How can we actually make the most of those? And one of the big advantages of this campus is that it's a multidisciplinary campus because of the great capabilities of the large science facilities and other research institutes. It has got incredible capabilities in space, energy, material sciences, health, you name it, it's all here. And we also have a very strong link to our other campus in the Northwest, which brings a big expertise in the digital world with the HAR3 computing capabilities, essentially. And also within this campus, we've had a very interesting investment in the past few months in the Quantum National Computing Center that will be developed by 2023. That is another fantastic capabilities added to this campus, which will also be the basis of our other cluster. So far, we've got 3 very successful clusters in space, and I can see Joanna Hart here that is running the space cluster. Energy, Emma Southwell-Sanders is the energy tech manager, and that cluster also has been growing really successfully and really fast. We also have a health tech cluster that again has grown really successfully and really fast. So through these clusters, we bring in together industry, academia, public sector organizations, to work collaboratively across sectors without boundaries, and that is the best way to actually exploit what we've got here, the public sector investment into R&D, and put it into real practice and really pushing the growth of our economy. Here I give you some examples. I'm not going to give you an exhaustive list of the companies that we've got here on campus. Just to give an example, we have 105 companies in space, and this is one of the companies that has actually come here as an inward investor just a few years ago, and has made a fantastic growth over the years. So just yesterday, before I went to bed, I was reading that they have secured an additional $109 million of investment, which makes, I think, a total of $300 million investment over the last few years. And they are working in removing debris from space and in-orbit manufacturing. Again, really an important field where the UK is really demonstrating leadership. And they are expanding on this campus. They are actually expanding their manufacturing capabilities on this campus. They have been working very collaboratively with a number of organizations on the campus. The Catapult in particular has been extremely helpful. But it's a real example of why and how companies are establishing themselves here to actually access our capabilities, access the knowledge base, which is one of the biggest benefits that we have here on campus, is the people, is the knowledge that we hold here, and how people can work therefore together on that. Another example that I wanted to give you is from another cluster, which is the ELTech cluster. Oxford Nanopore, again, completed that IPO successfully. And they started here about 5 years ago on this campus. They have been working very collaboratively with STFC, with the Science and Technology Facilities Council, very much using the expertise, but also the facilities, the clean rooms that we had here on site, and the experts around those. They now have developed their own facilities, and they are continuing to expand also the manufacturing here on campus. Again, the crossover with other technologies, Oxford Nanopore has actually run some experiments on the International Space Station a few years ago. They are very interested as well in the crossover with space capabilities and the application in space, especially as Paul was mentioning before. How do you, for example, keep astronauts' health in their missions? What type of instrumentations you need, and to actually monitor their health in space. And Oxford Nanopore, again, is again a fantastic example of a company that has benefited from this ecosystem here. Oxford Space System is another one that in the space cluster, and I think this is particularly interesting as an example of how we actually nurture the growth of companies from startup to scale up, and then hopefully really becoming big organizations. So Oxford Space System is placing itself as a leader in deployable antennas in the space sector. And they are expanding very fast here. Again, it's about manufacturing of innovative, using innovative technologies, but also innovative solutions. So they've been working with Oxford, for example, in the area, and others. So again, a journey going from beginning in the incubation support that we provided to now and expanding further in the future. But we are supporting companies, and I explained, how through the clusters these companies have access to our facilities knowledge base, also the finance networks. But we're not stopping here. Obviously, Harwell is a very large campus, has got a huge potential. We have got big expansion plans. In order to support this collaboration, you need to create a community spirit. And this is what our joint venture partner is really putting a lot of effort in. So we are developing new amenities. We're also looking at developing new houses on the site to support the growth and development of the companies that come and establish themselves. But also, one of the things that is very important, and I mentioned before, is the fact that this campus has got a fantastic community of experts that can be used to actually develop new ideas and test these ideas, and then also use these expert perspectives to understand what goes well and doesn't. And this is the type of thing that we use within our living laboratory. Living laboratory, which is about accelerating the development of those new ideas, testing them, and then rolling them out on a much wider scale. And I think that that type of approach is extremely important when you're thinking about, for example, solutions in the energy sector. You know, the big challenges that we've got in terms of timescales there. So we need to really push that forward. I conclude with a couple of examples in that, which is, you probably have seen this bus going around the campus, but if you haven't, I just saw it as I parked this morning. The bus is Darwin Bus. It's an autonomous connected vehicle bus through a partnership with the European Space Agency, O2, and others. They have actually developed this, which is a green solution. It's a solution that actually helps us keep our environment greener. And it's a fantastic example for the future of transportation. How do we actually keep all of us connected? Paul mentioned Westcott. You know, how do we actually keep all these sites connected? Transport is really important. So this is one example. And another example, which is really exciting, and Emma has been instrumental in making it happen, is a great collaboration between STSC, Reaction Engines is a space company, and then the investment from the IP group to actually establish a new company that will look at Jet Zero solutions for the future of transport systems. And this has been a success story which has been stimulated by the two clusters, energy tech, space cluster, coming together using space technologies with ammonia technologies to actually look at future green solutions. And with that, I would like to conclude and thank you for your attention.
My thanks to Claire, Peter and Barbara. November seems to be the month for events. It's all when we all go back and meet each other. So I know, having spoken to you all, you are extremely busy, so thanks for that. I picked up a tongue twister, I think, from Barbara, and it was referred to, I think, by Claire, was collaborating across close sectorial clusters, and that's something that we're very keen to make sure that we're doing. So thanks to all three of you for setting the context and giving some background. So we are now heading on to our next panel. So on digital manufacturing. So we had a run through of this earlier in the week, and we were talking about myths and myth busting, if I can say it properly, around digital. What does digital manufacturing mean? And does it mean different things to different people? So I think that would be one of the topics that we raise. So, but if I can ask Shaq to come to the front and introduce the rest of the panel. So if the rest of the panel can make their way onto the stage, please.
Okay. Just hopefully people can hear me. I've got my speaker on. So this is a session on challenges and opportunities around digital manufacturing. It's just kind of a discussion, really, with questions and answers. We'll introduce ourselves. I'll introduce myself first. I'm Shaq Goya from the Centre for Process Innovation. We're part of the High Value Manufacturing Catapult, and in one way or another, through all my career, which actually is 30 years now, it's quite a long time, has always, digital software and digital has always played an important part, be that automating factories, automotive factories, be that in the dot-com period, and also with my time in CPI, which I've been with since the start, where we set up the National Centre for Printed Electronics as well. So that gives you a little bit of background to myself. So I'll ask people to introduce themselves. Phil, do you want to start?
Hi there. So I'm Phil Ronson. I'm the Managing Director of MRT Castings, based down in Andover, just down the road. We produce aluminium die castings and machined components for a broad range of different sectors, particularly around sort of device manufacturer, so medical devices, defence equipment, marine electronics, lighting solutions, defence parts, those kind of areas. And we've been through a period of fairly dramatic growth over the last 2 years because our largest customer produces critical care ventilators. So the demands on us through the COVID period were massive. We had to scale up our operations threefold through the course of last year, and a big part of the way we did that was by accelerating our path to digital manufacturing, increasing adoption of automation and other digital technologies to massively scale up our facilities and really use digital to drive productivity, growth and collaboration with our customers.
Thanks. Try and follow that. I'm Charlie Young. I run a company, or run it jointly, called Plastron UK, and we're based down the road at Westcott. So we're in the space industry. We've got a background in basically space propulsion and launch site engineering. And we set up Plastron to basically deliver on safety, quality and productivity. Seeing the transition from the conventional space into new space, you see there's a lot of wisdom that can be drawn over, but it has to be fitted into a new model of supply chain activity to make it equitable with the goals of new space. So our work is around industrial facility design for hazardous processing of satellites, evolution of the supply chain, looking at new productivity methods that we can apply and enhance how things come to market, and fundamentally developing the skills of the workforce to make them fit for purpose and safe to work in the space sector.
I'm Pete Harmon. I'm from a company called CAE Tech. So we are a technology provider for the manufacturing industry. We develop bespoke cloud-based software, particularly for manufacturers of mass customizable and build-to-order products. So hopefully representing the technology providers.
Cool. So in terms of, say, facilitating some of the questions, I'm going to start with a question, which is a very logical question here, is what does digital mean for the manufacturing industries or manufacturing companies? Now, it'd be good if each one of you can go through and just give your own personal perspectives on that. Phil, do you want to start?
Sure. So I think we've already concluded in our early conversations that digital means different things to different people. From my point of view, we are obviously in the middle of that sort of manufacturing supply chain. We're a subcontract manufacturer, so we don't design anything ourselves. We manufacture customers' designs for them, and they then take those components that we've produced and generally they build them into the finished product. So digital manufacturing for us means embracing the best opportunities of digital technology, be that software or be that automation or new equipment, but particularly digital manufacturing and around the sort of Industry 4.0 sort of piece is about facilitating that flow of data through those various stages of the manufacturing process and making sure that data is used seamlessly wherever we can between those stages so that we can deliver the most productive and fast solution, but also so that we can maintain the integrity of that data. So if you think most design of physical components now starts off as a 3D CAD model that's been designed on a software package. Now, those of you who aren't involved directly in manufacturing probably aren't aware that in an awful lot of cases, actually that 3D digital design data then goes into a manufacturing site and they print those models out as 2D drawings, and then they start programming them into their machines, and then the part comes off that machine, and then it goes into another process where they start from scratch or from paper again. And then there might be metrology and inspection processes and sign-off processes. And those processes are, in a lot of manufacturing are very poorly sort of streamlined and harmonized. And so digital manufacturing, in our experience, is an opportunity to actually synchronize the flow of that data so that original CAD data flows straight into the next process and onto the next, and you're not playing Chinese whispers with loss of data integrity by it being taken from one system and put into another. And what that means we can do is we can operate much faster, we can actually deliver a solution that's much closer to the customer's original design intent. So it means a lot more use of automated machines. It means a lot of networking and integrating those different machines and those different software packages together. So that's what we've tried to do through our process, and that means we have had to invest a lot in equipment and in skills. But digital to me is about taking that customer data and trying to get it flowing all the way through to the manufacturing process.
Cool. And Charles, do you want to?
Yeah, I can't carry on after that
Yes.
one. So we're not manufacturers, as you might have guessed by what I was explaining, but we are recipients of that expertise. So in, say, the design of our plastron facilities, which we targeted going for a TRL6 off-the-shelf basic assemblies, because it's the cost effectiveness of that is evident. But we still have to work with design engineers and develop concepts to bring all these component parts together and make them work. And so in the manufacturing cycle, I look at it as that I kind of take a helicopter view because of just what our business does, and that is looking at those initial concepts and those requirements. And in the space sector, requirements are finite in the sense that they are the granularity of engineering design in the space industry is, to put it bluntly, is anal, but it's that finiteness gives you the accuracy of the product at the end of it. So understanding that requirement cycle as you go into your concept design, into the prototyping, the manufacturing, is really important because it's time consuming. And when you're dealing with really complex concepts such as like an optical telescope that's going on a spacecraft, you can't mess around. But the advantages that have come over the last 10 years feeding into manufacturing is that 10 years ago, if you wanted to design an optical telescope, it would take you 6 months to do the maths, and now you can do it in 3 days. And that shift is where the economy of scale starts to play into manufacturing. It's also where the cost benefits to the individual businesses, especially the startups, will start to really be determined. So there's, I think from our point of view, it's like seeing how the manufacturing cycle can enhance what engineering companies can achieve is one thing. Seeing how that helps the whole market grow is another. And that's the other bit that we're interested in. It's like saying, you've got manufacturing here, you've got design here, you've got other areas of productivity that fit into that model. But until you really understand and realise what the ecosystem actually is in its end-to-end definition, you're going to be suffering that problem that you mentioned, which is your data provenance will fail at the interfaces. And I had the pleasure of working with the NHS for 15 years around digital technology and that horrible word, integration, because it's the most federated and unintegrated system I've ever worked with. But we spent time and time again trying to develop strategies and digital transformation programs that would bring integration between primary care and secondary care. And the paradox was most patients assumed data flowed, and they didn't realise that there were people literally carrying bits of paper between sites to make the data flow. So I think getting that helicopter view of what digital will achieve for these sectors is really important, and learning the lessons from how it was done well in the banking sector is worth looking at. How it was suffered under the health tech sector, also the healthcare sector, is also worth understanding, so that we can learn from those mistakes and make the manufacturing sector in digital really, really quite smart.
Cool. And I suppose here what we've got from both of yourselves here is data is very important here. And data integrating processing activities, and that in a way interestingly brings us on to, Peter, what in your kind of area, which is, I think you said earlier you were talking about cloud-based systems, and that to me visualises being able to bring data together into a central place.
Yes, it is. We're very much to echo some of what Phil said about the use of CAD data through the process. I mean, my background actually is mostly on the design and simulation side of things, and I've only got onto the manufacturing side of things in the last few years. And very much what I've then seen, or been quite surprised by, is that there's still this big disconnect between the digital technologies on the design and analysis side of things, and actually then how that data is used in manufacturing. So what we're trying to do is to maximise how that CAD design data can be used throughout the digital thread, as it's now being termed. But you take CAD data all the way to the factory floor, essentially, rather than having these processes where someone, as Phil says, prints out a drawing and then scribbles stuff on that, and then that's got out of date with some design changes that have been made, and so on. So it's making those kind of processes better. I think I've seen another thing that I've seen sort of coming into the manufacturing industry is that a lot of talk about digital is about analysing what's happening in the factory and whether that's correct for quality and for an efficiency, which is very important also, but I feel you need to get the first steps right first. So I think it was mentioned in one of the talks earlier of design for manufacture, but actually making sure that your design data is fed to your manufacturing in the best possible way, and that there's feedback to the engineers designing things that what they're making is manufacturable, and then you're starting with a more optimized process once you actually get to manufacturing.
Cool. And before we open out to the audience, and I was just going to build on one of the elements that you said earlier, which was getting the first steps right. And I think it would be good to get all three of your perspective on how does a small company, like a startup or an SME, who may not be heavily automated at all or using a lot of digital, how do they get started? So what are the first steps? How would a small organisation make those initial steps on their journey on digitalisation? Because it's a huge journey, it's quite a complex and challenging journey for many.
Yeah, I mean, you're right, Shaq. It's a huge journey, and it can be quite daunting, particularly for a small business that maybe doesn't have an awful lot of resource in this area. So I think the key is, from my own experience, I was sort of standing on the edge of this sort of space, observing for a number of years, thinking I really want to take us down that journey, but now's not the time. It's too big. We haven't got the right people. We'll wait until things calm down. And you can keep putting things off like that. You've got to start small. Pick the low-hanging fruit. Look at a very simple process where information is handed from one stage to another. If I give a relatable example, in our CNC machine shop, so CNC machine tools, we're machining lots of different components. We're setting up fairly regularly. So every time you set up a new part on a CNC machine, you have to measure your cutting tools, your drills, your mills, your taps, and you put those into the CNC machine, and you tell the CNC machine what the offsets of those tools are, what the lengths of the tools are. So we used to measure the tools offline, write them on a bit of paper, and then go to the CNC machine, stick them in the machine, and type in those numbers. Now, inevitably, first of all, you'd got errors in the actual manual measurement. Then you've got errors when the information was being keyed in, because someone with fat fingers had punched it in and put the numbers the wrong way around. And it all took time. And you didn't know you got it wrong until you made the first part, went to check it on the CMM and found it was out of tolerance. So first thing we did is we bought an offline tool measuring machine. So we did that, and that was great. That overcame the inaccuracies of the machine. But actually, even then, with the latest technology, all that did was it gave us an output of a report, a printed report that you could then take to the machine and key it in. And so we actually challenged that with the machine tool manufacturers and with the measuring manufacturers, and said, hang on, there's got to be a way we can get these things talking. And they're saying, oh, well, they're all Industry 4.0, enabled devices. But when you talk to them, all they really meant was they'd both got a network socket on them. Mm-hmm. But they'd got no integration of that data. Now, actually, we then worked with MTC. We developed a means of outputting that data from the measuring device, loading it straight into the CNC machines, and what was taking us 20 minutes and a lot of manual effort suddenly is now integrated. So you measure the tools, you put them in, the data flows in, and we've saved ourselves 20 minutes on every setup. We've saved ourselves a lot of inaccuracy, but it was a very, very simple process with just 2 steps, just 2 types of equipment that we've got to get talking to each other. Once you've started there, you grow in confidence and you can build from it. And also, you can justify the investments in the bigger spend items once you've shown the benefits of doing some small things. And you win the confidence of your team. Maybe if you've got to justify your financial investments to the powers that be upstairs, you can say, look, just that small step has saved us X thousand pounds a year. So start small would be my message.
And I think one thing I just heard there was a difference between Industry 3.0 and Industry 4.0, i.e. computing and digitalisation. Correct me if you have a different perspective, but in Industry 3.0, you would be doing the data entry. You'd be taking those measurements, putting on a piece of paper and taking them off and entering it onto a computer where the data will be collected. In Industry 4.0 or digitalisation, we're referring to that whole stream being automated. There's data's been captured and the system's been updated, as it were. So that's a key difference. Yeah.
Yeah,
Charlie?
I think my views are very similar, and I'll probably use healthcare as my example here because it feels so relevant. So digital transformation in healthcare was either seen as a burden because it meant changing everything in sight, or it was seen as an opportunity for improvement. And one had a very positive connotation, one had a negative connotation. And we saw that it was very much about improvement. The road to improvement can either step change, it can be massively disruptive in huge steps, or incremental. But what digital offered was a means to turn that into a really manageable process, which in a high evidence-based industry like healthcare is really important, because if you disrupt things in the wrong direction and you cause damage, like Theranos is a good example of how not to do it, you cause a lot of problems for everybody, and the whole industry can suffer because of that. So we saw this transitional program really, which we learned a little bit from looking at banking, but we tried to implement into healthcare, which was your first step is about tactical. And it is, like you say, low-hanging fruit. It's like, what could we do, what we're doing at the moment, without changing the system, without changing the service model, but what can we automate and digitize just to make our lives a little bit easier, take some waste out of the system and make ourselves more efficient. As you do that, the first thing you start to do is realize where waste actually is occurring elsewhere in the system, and you start to think about it in a much more strategic way. But you still have to fix that stuff before you can go into strategy. You never dive into a strategy of mass transformation because it will never work. And it'll be very costly, and you'll get a huge slide deck from consultants that you never look at. But once you've got the confidence of that tactical change, then you can start to develop a strategy, and it might be a 1 year, 2 year strategy, it doesn't matter, but it is where you're starting to really turn your entire continuum into a digital asset, or supported by digital assets that talk, that communicate, that optimize, and then you start to derive greater benefits. The next stage, and the bigger one, and I think this is quite open-ended in some ways, but it's where you start to go for systemic change. And it could be saying, okay, well, traditionally we do tactical change here, we've now evolved our system, but we're still within the system that we work in. But now we've got new system input saying we have to be sustainable, we have to be near zero. So suddenly your system model becomes much bigger than the continuum that you work in. But those inputs give you the opportunity to invest into the future in a long-term model that has got, I think, a level of future-proofing that you wouldn't get if you were just in the strategic model. So I think that those are the kind of stages of growth, that they offer a level of security and pragmatism, but always allow you both to be in control of change, which is really important, because otherwise you scare everybody and they go and get a job elsewhere, but keeps them in a place where they can also engage with it and actually be part of that change transformation. Because I think any transformation is as much about the people as it is about the industry and the business that you're working within.
Yeah. And you mentioned you're in healthcare.
I used to be.
I used to be.
Still healing the scars on that one.
All right. Okay then. Okay. So Peter, do you want to build on this?
Well, so yeah, on that last point, I mean, so we kind of have two types of customer. We've got some customers who are startups, so they're actually creating the technology in the first place. They need our technology to manufacture the goods that they want to be able to do. But we do actually work also with existing manufacturers. And on that, the last point, that it's the people is the key thing, that we're trying to identify a pain point that's the most efficient thing that you can actually improve with the digital technology. But you actually want the improvement to be enough of an incremental change that you're not going to get too much resistance.
Yeah.
So our a good example of that we've done this year is we were part of the Made Smarter Technology Accelerator, and we worked with Babcock at Rosyth Dockyard, and it was a communication issue around CAD, so they wanted to put 3D CAD in the hands of their factory floor team, who were not going to log onto a computer and use a CAD tool. They were not going to put on an augmented reality device, and they were quite keen to hang on to their 2D drawings and didn't want to move away from that. And so what we designed and developed for that was a solution where they can look at the 3D CAD, but using a tool that is totally intuitive. You can come and try it out if you're here in our demo in the other room. You're using a set of buttons, an Xbox controller, so it's sort of not completely changing the way that people are doing things, but it's enough to mean that then the team on the factory floor they're able to self-service, essentially. They're not constantly going back to engineering and asking questions, and any issues that they raise are logged in software, with a date and time, so there's traceability as well on any concerns, any issues that have been raised. And so it's similar to the example of measuring the CNC tools. It's finding that thing that is a pain point for the actual manufacturing, and the solution is not ripping out the factory and starting again. It's finding something that can solve that in a way that people can accept.
Cool. And I think it would be good now also to open up for questions to the audience as well. And there should be a mic. I can see one hand up at least.
Hello, I'm Emma Sandra, managing the Harwell Energy Tech Cluster. So to the other extreme, I just have a quick question that I wanted to ask about quantum. So we've got the Quantum Computing Centre becoming established, and we were in a session with them yesterday who were saying that quantum can be a threat because of the security and encryption in our existing systems, and as that's developed, they'll be able to crack the codes behind the security much more quickly, but can also provide a base for exponential growth. So looking at forward modelling capabilities, linking directly to products and manufacturing. And they want to start looking at applications to industry sooner rather than later or now, and think that there's a lot of potential in sort of projects and collaboration around that. I was just wondering if the panel had any thoughts yet on quantum and how that might be applied to their organisation.
Does anybody want to?
I'll have a go. I mean, I don't work with quantum myself. You don't really need it, I suppose, in safety. But I've done some work with a quantum startup, Quantum Dice, I think, just based up the road in Oxford. And what they're doing with their technology, which is, I think, in a very high TRL level, but it's not commercial yet, but moving that into the space domain, and the kind of issues that faces, developing something hardware like quantum for the terrestrial domain is very different from the space domain, and the transition to get to that is an additional challenge that they're going to have to get to show that it still works in that location. So that doesn't really offer much of an insight, really, does it? But I suppose that the value in space of quantum technology, the techniques, is going to become increasingly vital. And you've got a company called Arctic who are working with BT to orbit chips, aren't they? They're going to have quantum chips, so you can have terrestrial communications like ground to space, and also space to space communications which are encrypted. China are doing it using lasers as well. So that ability to own your data from the space domain down to Earth is going to be, I think, I suppose I wouldn't call it a battleground, but it's going to be a challenge space, because people will try to be, there'll always be disruptive actors, and this is just the next level of security that's going to be put in place.
I think from our experience, I mean, yeah, we're not in the quantum world, but as computer power progresses, it's a powerful opportunity for processing. If we take things like for our casting process, we use some very, very powerful simulation software. Now, some of those simulations can take a week to run, and if we could run them in a few hours, that would have great benefit for the whole process. But equally, we have some of our customers, particularly around the defence sector, where they are very risk averse to data being, kind of exploited. And in fact, we can't. There are some of our defence customers where we can't use any of our digital manufacturing tools, even in the current space, because they don't want anything, on systems that can be accessed from outside, and there isn't really the security standards around that they've got the confidence in for that level of data to be out there. So I think it's, from a manufacturing point of view, going to have to be a tough debate. But yeah, it's clearly got opportunities and challenges.
Peter?
I'd definitely echo the any speeding up of processing for running simulations benefits us because the more that we can analyse a manufacturing process in advance, then the more optimal we can make it. One thing I did mention is that everything that we deliver is cloud-based, and so obviously the topic of security does come up for us quite a lot. I think companies are getting more open to the idea of data being cloud-based, but obviously around defence, that's still an issue.
I get to add to that, just a thought that came to me. I mean, the advent of quantum in computing is inevitable, and that's not just because it's something shiny and new and has got some interesting applications, but we're reaching a point where simply the size of design work on computer chips, we're reaching the peak of what we can do in terms of making transistors and circuitry small enough. We're getting down to nanometers, and I think it's like 10 or 5 nanometers now is the peak design level. You can't go much beyond that before you actually start working between atoms. So quantum's going to take over if you want to keep increasing computing power. That's a fundamental expectation, I think, from the industry.
Yeah, and I think it's more specific types of applications as well, from what I understand. And one of the recent ones I came across, interestingly, was with the medicine discovery catapult. And we were in dialogue and looking at different ideas. Actually, we were talking about net zero, and somebody put forward using quantum computing for drug discovery. So you can actually very quickly identify an active ingredient and therefore kind of reduce the lab work which is required around that as well. So I think there's got some very niche target applications, as it were. Questions? There's a hand here.
Okay, quick question then. So I'm going to try not to comment on the quantum piece because it's just so fascinating. However, one thing I did have a question for Charlie. You were talking about, you're kind of in a sense defining the systems and integrating systems and working with manufacturers to supply you some of your components and subsystems.
Yeah.
What do you see in terms of the challenges between, let's say you come up with a design that meets the requirements and then needing to work with multiple suppliers and actually getting them to work with your technology towards your designs?
Yeah, that's a really good question. We're going to learn that one very shortly. Because, I mean, certainly we've designed this facility called Plastron, which is basically it's a modular construction for basically handling satellites in a hazardous situation. And our supply chain is made up, I think, of about 20 different suppliers. And like I said earlier, apart from one small component, everything is off the shelf. So we've had to, we basically had to learn how to do basic CAD design. You know, when I was doing it at university, it really was numerical on the side of a milling machine, and it's a huge step forward since then. So understanding how stuff comes together, fits together, is one component. Understanding the sequence of it and the planning around that is another big step as well. And in fact, in some ways, I think the challenge of getting stuff built in sequence is more significant than making stuff fit together. Because at the end of the day, as an engineer, your job is to solve problems. I mean, this is where the work that we came in with Catherine and the MTC with their Digipop program, because basically we said, right, here's our assembly, we've got all these subsystems, they all come together, this is the sequence of how they all fit together, but we don't know how to plan it because we've never done it before. So without actually building anything, we sat down with their team and they designed a model that enabled us to look through the process of assembly, apply criteria about how it would be assembled, with sort of risk factors and so forth, and came up with this model that I think gave us something like between 150 and 200 days estimated elapsed time to build this facility, which otherwise would have just been guesswork on our part. So from that side of it, the assembly of the components has been a really interesting exercise to get into. When it comes to actually putting stuff together, when we start to build our first ones early next year, there'll be a whole new level of, right, why, those things should butt up because we designed it to, but actually we've got these offsets, what are we going to do about it? And I think part of engineering is always about that in situ problem solving. It's the bit that makes that analytical brain sort of spin and get the cogs working.
I think there were a couple of hands. There's one hand earlier here as well.
Thank you. We have just launched a digital tech cluster in the Northwest this week, which is really built on the capabilities of the Hartree Centre and the innovation expansion of that centre. So what I'd be really interested to understand is how can you benefit from such a development? So what are the key things that you'd want out of such a development? You know, in terms of a new cluster, Phil talked about, you know, what challenges you faced at the beginning, you know, having to, you know, build your portfolio of capabilities step by step with something that allows you to access something available that is shared, you know, amongst a number of small companies, be of use to you, having access to capabilities, knowledge base. Tell me, what would make a difference to you?
I think the opportunity of any cluster is sharing best practice, isn't it? And sharing the, you know, the wounds of experience. You know, we all learn best by making our own mistakes, but we could learn even better if we could share those mistakes with others, so that they don't have to fall down the same pitfalls. I think the key is, for digital manufacturing, you're trying to integrate a lot of different technologies. You know, under the umbrella of digital manufacturing, you know, we've already talked about everything from CAD data to CNC machines to simulation to, you know, integration between, you know, the customers and their supply chain. You know, there's a lot of different players, and really, if you're going to have a flow of data down all of those disciplines, you need to have covered all the bases. So you've got to get everyone in the room. You know, so you can't just have a group of manufacturers in isolation. You've got to have the customers. You've got to have the technology providers, and also skills are always going to be the biggest barrier to any new technology. You know, and so actually, you know, sort of training programs obviously are a very effective tool if you can cluster them. And yeah, that sharing best practice, I think, is probably the biggest opportunity.
Excellent, thank you.
Cool. And there were actually a few hands up. There was one right at the back. Let's make sure that the hand right at the back wasn't missed. We'll come back.
Hello.
Hey.
Good afternoon, gents. My name's Anthony Oates from Abingdon Verification Instruments. I just wanted to know how test and verification fits in with the things that you've been discussing this morning, what your approach is to verification of clients' products and so on and so forth. It's a question not for anyone in particular, it's just for the panel.
I'm happy to dive in on that one, others can pick up. I think, you know, going back to where I started of taking a customer's design and making sure that you maintain the integrity of that design. And as Charlie was saying, obviously, you know, sometimes you can have an awful lot of different players in this, you know, in this chain. And so you assume that because you've designed something and all the bits are going to fit together, that actually, when you then get the bits from lots of different manufacturers, they're all going to fit together. That only works if the manufacturers have produced exactly what you designed. Mm-hmm. And your design worked in the first place. Mm-hmm. If I take the ventilator project that we've been working on heavily in the last couple of years, so these critical care ventilators that we've been producing, we make 21 components on the ventilator. The ventilator as a whole has 1,100 components produced by 106 different manufacturers in 14 different countries. Now, the only way that all bolts together is if everyone makes exactly what was designed within the tolerances that they were designed for. So the only way that the customer can get all of those components in from 14 different countries, 106 different suppliers, and know that they're going to bolt together right first time, is if each of those manufacturers is using verification. If they can measure those parts accurately and have a production process that's repeatable enough to deliver you know, that. And so increasingly we're seeing customers specifying that we need to achieve statistical process capability, you know, so that they've got the confidence that those parts are always going to fit together every time. But we have to educate customers very often that they design something, we go, well, that design's all well and good and it looks very sexy and it's very clever, but actually I can't measure that. And if I can't measure that, it's not worth putting a tolerance or a dimension on a drawing if there is no way of measuring it, because I can't guarantee it. So we actually have to incorporate that validation process into the initial design for manufacture, and that's quite key.
Cool, thank you.
Cool, and there was a question here as well. Okay.
Hi, I'm Cliff Jolliffe. I work for a company that provides very high precision robotics. So we typically supply to machine builders and to end users. But question for Phil, I think what you said actually all through has been really interesting and gives some good insights. So when you decided you needed more equipment, did you really think about Industry 4.0 when you went out to buy the equipment? Was that a key factor, or was it what the machine could manufacture? Because it does sound like there were gaps in between the way that the machines network together. And do the vendors really understand what Industry 4.0 means?
No, I think in my cynical view, Industry 4.0 to most of the vendors means we've put a network socket on it and it's used as a standard, programming language. And so if you wanted to, you could integrate it, but we don't know how, and that's your problem. It's that simple. So did we consciously set out to it and to do it? I think we've been investing heavily in new equipment, and new equipment tends to come with those capabilities, but we soon started to see the opportunities, and so yeah, we've embraced that. But yeah, the difficulty is that you've got different machines that are doing different things, and so their software is designed to work differently, and so the original architecture of those, they weren't necessarily expecting to integrate a CNC machine with a die casting machine, because that wasn't the end goal. So yeah, it's a challenge. Integrating robotics, I think, is more standardized. I think we're finding it quite easy to integrate robots with a wide range of different machines. I think getting those machines to talk to each other, through the different processes of a manufacturing cycle is more challenging.
Can I just ask you a question about that, Phil? Because that comes to mind for me, and this is just seeing the translation from working in digital tech, in my experience in healthcare, translated in what you did with the machine shop, or with the workflow, the shop floor. And that is, you start out with basically coming up with your technical architecture. You're saying, right, we're going to have a server there, this is this, you've got all the component parts that make up your technology system that you then can put your software, your applications onto, and it's going to work. Did you go through a design phase in working out all the equipment and what it needed to do to comply to with the middleware or whatever, so everything would actually link up? Or was it
originally, no. We sort of did it by accident. So we have a network around our factory. All of our machines we plugged into the network because it was a convenient way of backing up the data on them. So we were just using it for that. And it was then as Industry 4.0 started to become, a hotter topic, and there was a bit more, sort of awareness of it. We started to say, well, look, we've got this expensive kit we're only using a fraction of the functionality of it. We've got the infrastructure there. Let's use it for something more productive. We've then taken that further, and since we've built a new facility from the ground up, and we have designed that completely with Industry 4.0 in mind, and the infrastructure to support that. Yeah.
And big benefits, I guess.
Yes,
definitely. Notable.
Definitely, and exponential opportunities for those as the equipment and the technology catches up with our aspirations, if you like.
Nice.
Cool. I think we've just got a couple of more minutes left, and I think it would be good to get some concluding remarks, as it were. And I think maybe one area to look at, actually, in these concluding remarks, is that we're about to go through over the next couple of decades a lot of transformation, not just digitally, but also because of net zero and climate change. And I just thought maybe you can make some final remarks on the convergence of these two and how digital can help in terms of net zero, or in terms of net zero, shall we say.
I'm conscious I've done a lot of talking, so I'll keep mine short. I think in net zero, monitoring is key, and digital, gives us a lot of potential for that. So actually monitoring the OEE, the uptime of your machines, and the energy consumption of them, I think is key. I think also digital, in my mind, is key for productivity and quality. And actually, one of the fastest ways I keep advocating of driving down improving our energy efficiency is to make less scrap. So actually, if you can use digital to improve your yield, then instantly you're reducing energy consumption. But I think a combination of productivity, yield improvement, and monitoring would be key for net zero.
Cool. Charlie?
Yeah, net zero, I mean, we're working on an initiative at the moment, a small group of us in the space sector, focusing on sustainability, and we're calling it near zero, because we think the objective has to be pragmatic enough for people to get there and not feel that it's an unsurmountable objective. And within that, you know, I come from a systems thinking mindset, so I always bang on about systems, and if you know me, you're probably bored of hearing it. But when we look at, say, the manufacturing of a satellite, so for instance, at the moment, the carbon footprint of a scientific spacecraft from ESA is about 15 tons of carbon. That's the offset. So the starting point is, you know, the bar is quite high at the moment, but it shows there's a lot of waste in there that can be achieved. So to walk towards sustainable practices means that digital will play a huge amount, because you can start to think about open source components, so you don't have to keep reinventing and redesigning a bracket every time you're building a new bespoke spacecraft. The more that can be off the shelf is going to make a difference here. And I think digital can play a part both in the design of those, but also the quality control of that as they're implemented to make sure that they're fit for purpose. Yeah. So I think taking a systems approach and looking at from the cradle to grave of the of products, both in their entirety and in their component parts, is where we can start to derive benefits. But we need to understand, you know, we need to define the system that we're going to do that in for sustainability.
Cool. Yeah, Peter.
So at the lowest level, we're working on things like optimizing nesting of components for CNC and optimized tool paths and so on, so maximizing yield and reducing energy. But our general overview that the area of manufacturing we're focused on is this idea of mass customization and build to order. That can include configurable products such as space products that might be assembled from different off-the-shelf components, but very much this idea that every product the manufacturer makes might be bespoke. And we're viewing that as being positive for sustainability, because you're only making something when someone wants it, so you're not just manufacturing loads of stuff and trying to sell it. You're making it exactly how the customer wants it, so they're more likely to keep it for longer and reuse it. And you've got the opportunity to manufacture it. If you use digital correctly, you've got the opportunity to manufacture it where they want it as well. So we've got some use cases where actually the manufacturer makes the goods closer to where the customer is who's ordered it, because the manufacturing data is sent digitally to a local contract manufacturer.
Excellent, thanks. And I'd just like to thank our panellists, Phil, Charlie and Peter, for answering our questions. Thank you.
Thank you.
Thanks very much to you all. A really insightful session. So in a moment we're going to go to just a short break. I thought I'd set myself a challenge of how many slides I can get through in 90 seconds. So bear with me. This is the advertorial break. So I just want to tell you a little bit about some of the exhibitions that we've got going on. We've got the Product Manufacturing Incubator talking about the design for product manufacturing. We've got the Manufacturing Support Service specifically for the SME community, and we've got the Oxford Advanced Skills. We've got a couple of apprentices in there on looking at a robot cell, so see what they're doing and go and talk to them. So I'd just like to mention some of the demonstrators. So they're here in this room and also in the demonstration room over the way. For those people who are online, they're also in the interactive guide that we've put together. So the first one that I'm showing here is the engine air brake. So this was designed by the National Centre for Additive Manufacturing at the MTC, a jet engine air brake to demonstrate the potential of metal powder bed fusion additive manufacturing processes. The next one is FEMS, the future of electric motors, a way of producing an electric motor with major components using additive manufacturing, giving an increased motor power with a reduction in size and mass of key components. We then have Seamless. This project set out to develop an automated, flexible and precise finishing solutions for AM, achieved through multiple robotic finishing techniques and just in one cell. We then have the below-the-knee prosthetic leg. Current methods of prosthetic socket manufacturing are laborious and time-consuming. The MTC developed a digital workflow to design and build a customized socket with pressure release features and adjustable mechanisms for a better fit and user experience. Product circular economy, how to take a toothbrush apart in this instance, demonstrating how you can build sustainability in product design to reduce waste by using design for disassembly and human-centered product design. And then we have Reacher, In collaboration with the nuclear industry, the MTC have developed a novel remote handling demonstrator in hazardous environments, which brings together a range of innovative technologies, removing the need for traditional manual glove box processes. And last, and by no means least, we're very proud of this one at the MTC, is Emma Wiggs's paddle. So the MTC and the National Composite Centre came together with Paralympian paracanoe champion Emma Wiggs to use the latest manufacturing technologies to design and produce an improved, personalised handle and paddle. It helped propel the 8-time world champion to victory in the new VL event, winning her second successive Paralympian gold medal at Tokyo 2020. I think I did that in 90 seconds. So it's time for a short break, and please grab some refreshments. I've got the agenda is for 11:20. I think we're just a few minutes by. So if we say 11:25, when we head on into our second panel discussion on automation, and we're picking up some of those previous themes around adoption barriers and how to overcome them. So see you in 20 minutes. Thank you. Without more ado, I'll hand over to Mike Wilson, the Chief Automation Officer at the MTC, who will introduce the session and the panellists. Mike, thank you.
Thank you, Chris. Before I kind of introduce everybody, I just wanted to say that for those people that are watching online, if you want to put any questions into the chat, we will be very happy to try and answer those when we get later on into the session. So I'm very pleased to be here today. We're going to be talking about adopting automation, which is a subject very, very close to my heart. What we've managed to do is put together a group of experts, people that have been around the industry quite a long time, to help us discuss that. And one thing I wanted to stress, that these are all from relatively local businesses. So we've not gone to necessarily the usual suspects from across the whole of the UK. We try very hard to find people that are working in businesses in the sort of Oxfordshire area, Oxford-Cambridge corridor, to make sure that we get a local viewpoint on this. So just to very briefly introduce myself, and then I'll pass on to the rest of the panel. I'm Mike Wilson from the Manufacturing Technology Centre. I've been doing robots and automation for a few years now. I actually started work at Cowley when it was British Leyland back in 1982. And at that point there were, I think, very few robots on site. They just put the metro line in up at Longbridge, which had about 25 robots on it, and they were just installing, for those old enough to remember, the Montego and the Maestro, and they were putting a few robots on those. I worked in the car industry, I worked for the robot suppliers, and I'm now at the Manufacturing Technology Centre. And principally what I'm trying to do is to help UK manufacturing adopt more automation and robotics. So with that, I'd like to introduce the rest of the panel. So Jeremy, please.
Good morning. My name's Jeremy Haddle. I work here at Satellite Applications Catapult, where I'm robotics development lead. What that means is we're looking at how we use robots to support the work we do with satellites, either potentially manufacturing them here terrestrially, but more importantly, actually, what do we do when we're looking at some of the more futuristic, if you like, applications of satellites in the future, and some of the, as Paul mentioned, space-based solar power. How are we going to build that? That's obviously not something we're going to do with astronauts, because it's a big, very big spacecraft. So how do we do that with robotics? And previous to that, I spent 25 years working in robotics and manufacturing, not quite as long as Mike. I've built a few cars in my time as well, mostly for Ford and GM, and thrown crisps around with robots, but that's my background.
Thank you, Jeremy. Volley?
Thanks. So my name is Volley, and I run a company called Vicaso Limited. We're a new company, started about 2 years ago in February last year. I know it's perfect timing. So we specialize in collaborative robots. So our work spreads across various industries, typically going from manufacturing all the way to the print industry and the drone service sector. And my background is in automotive manufacturing, so I also used to work at the BMW factory in Cowley for about 5 years before we started up the initiative of Vicaso. So I'm looking forward to the conversation today.
Thank you, Volley. Ben, over to you.
Thanks, Mike. Thanks for inviting me. I'm Ben Chowdhury from Creative Robotics. We're a robotics software platform company that's developing software for operating, managing and productizing robotic systems, particularly remotely operated ones. We were also only founded last year as a spin-out from a larger nuclear robotics and sensor company. We're developing technology that we hope will be helpful for the robotics adoption and also for the general robotics community as well. And so we've been working mainly in the nuclear sector, nuclear decommissioning, so not really manufacturing, the opposite of manufacturing, dismantling stuff. But I think hopefully we can bring something that's useful for the conversation.
Thank you, Ben. Steve.
Hi, I'm Steve Sanders. I'm the manufacturing director at JSP Limited, which is basically a PPE manufacturing company. We're based locally in Witney, Oxfordshire. The reason I'm here is for the last 13, 14 years, as a business, we've been through the journey of automating most of our production. So we're proud to be UK manufacturers. We manufacture the lion's share of our products that we sell in Oxfordshire, and we've done that just through hard work, dedication, and an awful lot of robots.
Thank you. Thank you, everybody. So I think we'd like to start talking about adoption, and I could bore you with lots of statistics about how poor the UK is in terms of adopting automation, so I'm not going to do that today, but let's just say that we're 24th in the world in terms of a league table in terms of robot density. So we're behind most of our major competitors, and that's in manufacturing. But I think we also, with the panel here, we also want to talk about how we might be adopting more automation in other sectors as well, things like space and nuclear and so on. But I think I'd like to start really by talking a little bit about manufacturing and maybe go back to Steve and just sort of, maybe Steve can sort of give his thoughts in terms of why he thinks UK manufacturing is not adopting as much automation as the rest of the world, and from his perspective as a significant robot user, maybe why he's seen some benefits from doing it.
Yeah, it's a very good point. I think pretty much up to recent times, it's because people haven't had to. There's been this sort of easy, ready supply of labour. It's allowed a lot of flexibility, but with that comes, it's difficult to manage a large group of people in factories. So, it was quite a number of years ago now, we bought in our first robot, and the only reason we did it was because the job was particularly dangerous. We didn't like the idea of someone climbing in and out of an injection moulding machine, a 1,500 ton injection moulding machine carrying parts in and out. And we said, well, we'll put a robot on to do that. And as soon as we started sort of looking at how that worked and what it was doing, it was an eye-opener. And as a manufacturing team, we said, we could do this just about everywhere. And it's kind of snowballed since then. So the way we look at our manufacturing now is every time we come up with a product we're going to bring to market, or we're changing our product range, we design the product around automation and vice versa, so that we would never put in a new product now without actually automating everything that can be automated. The advantage for us is now that in terms of sort of manual labour, we don't struggle because we're pretty much automated all the way through. It means we've got massive cost advantage now. So the automation allowed us to be on parity with a lot of the imported product, and we could supply on a very lean basis, so low inventory, as the accountants say, high earns and turns. What's actually transpired in the last couple of years through the pandemic is that the supply chain has effectively fallen apart. Most of our competition can't get products, components, you name it, into the country, or it's taking an awful long time. And the end result is we've just found ourselves in a hugely strong position in terms of being able to supply products to our customers in the same way that we always could, at a massive cost advantage now, because I don't know if any of you import goods from overseas, it's $14,000, $15,000 for a 20-foot container coming in now. So if you've got 500-600 products in a container, all of a sudden the cost base for that product has changed dramatically. I'm here because I'm a passionate believer in UK manufacturing, and going back to Mike's original point is, why are we so poor on the uptake of robots? It's beyond me. I think it's been too easy for people not to have to persuade the accountants to make the investment, not to do the hard work, and I'm very proud that at JSP we've done that hard work, and it's now paying the dividends massively for us as a business. And I'm here so that if anyone else really wants to consider that journey and what it takes to do it, I'm here to help. I'd love to advise. I'd love to see UK manufacturing really sort of get a grasp of what they're capable of doing, rather than sort of saying, "Oh, let someone else do that." I think that's the soft way out. And I'd like to see a room full of people who are actually saying, "No, we can." What did I describe the other day? I said, we're the engine of the UK. Most of the time, the bonnet's shut. No one cares what happens underneath it. Yeah. Until something goes wrong, and then they lift up the bonnet and say, "Ooh, that looks complicated," and shut it again. And the truth is, for UK to really motor along, that engine needs some attention, and everyone here is that engine. We're the ones who are driving the revenues for the UK. We're the ones who are going to drive the tax returns and everything else going forwards. So that's my point.
Thank you, Steve.
Yeah.
Volley, from your perspective, you're going into different industry sectors, different types of businesses. Do you think people are starting to appreciate that they really do need to adopt robots, and why do you think that's happening?
It's quite different industry to industry, I'd say. I mean, in manufacturing context, I think what we usually see is people are a bit reluctant to take risk. And that's just been a cultural thing we usually see in manufacturing companies. But some of the other industries, if I give you an example of the drone service sector that we started to work with, they had a completely different approach. So they started off with an idea where they said, okay, we want to swap batteries in drones every 3 minutes. And essentially they were in the position where they said, okay, we're just going to throw X amount of money at it. If it doesn't work, it doesn't work. If it works, it works. We are starting to see that change in the manufacturing world now. I think in particular after Brexit and what the shortage of supplies and the shortage of labour is now what's resulting into it. It's actually forcing manufacturing companies to look at different ways of making their products. Obviously automation is one way to reduce the need of having labour in your factories. So we see that changing, but we don't see that changing fast enough. So definitely it is the case that manufacturing companies still are quite reluctant to take a risk and step into something they maybe have not done before, and accepting the fact that, okay, sometimes it may work, sometimes it may not. But we're certainly starting to see that increase with small manufacturers. The larger manufacturers naturally are just quite slow in the way they proceed with things. So multiple things we've personally seen from our company is the speed at which things move in companies change. The level of risk they're willing to take also differs. And I think the one thing that we do see as a successful formula for automation to work is a balance between the two, is increase the speed at which automation is deployed, at the same time increase the willingness to take risk. And this combination does work. It has worked for some of our applications we've already done.
Great, thank you. Ben, from a nuclear perspective, then, I mean, obviously that's it's probably best to say a fairly risk-averse industry, but they need to look at technology as a solution to some of the problems. Do you think there's any lessons we can learn from that sector in terms of what they've done and how they're doing it?
Well, I think one of the interesting things about the nuclear sector is that there's obviously the pressing need to adopt robots. It's dirty and dangerous work that today people are being put in harm's way to do. But there is this, as you said, it's a very risk-averse, very regulated industry. There's also a lack of understanding and education about what kind of robotics technology is actually available and that could be applied to their problems. I don't know if that's something that's the case in the UK manufacturing as well, is that we just don't really realise what the like what's the capabilities now of new technologies that are really quite mature, such as cobots, and just general control software and different sets of technologies that are now off the shelf, increasingly low-cost products that are very technically capable. I don't know if that's something that either like Steve or you can maybe comment on, the sort of customer education, or what in the nuclear industry they call the intelligent customer, and how to make them. I
think you just got to go from a point of view is what can't you do, not what can it do, what can't it do. If you sort of always have that mindset of then you're going to win. And you go back with the risk bit as well. Every project we've done has had risks. Every single project has worked in the end. You've just got to, you've got to be tenacious. You've got to really think it through, and the partnership you have with your integrators is absolutely fundamental. If you're going to go out there, sign a contract, beat them to death over price, and then expect them to create the world and it all work, you're going to fail. If you're going to go in there with a collaboration, realizing that you're doing something no one else has done before, it's going to take time. It's never going to deliver what you actually set out to do. Sometimes better, sometimes worse, but it's always going to be better than where you were before. That's the risk bit, and I think anyone who's thinking about this journey has got to do that. If you are sat buried in payback cost calculations, you fail before you start. It's a very different journey. It's as much as the cost saving, it's how your company then becomes, what it becomes after that, how you're seen by your customers, how you're seen by your employees. It's a proper journey. So, yeah.
Thank you. Jeremy, obviously space is very different to PPE manufacturing, but do you see anything in terms of technology or sort of risk profiles and so on that you can use when you're looking at the applications you're going to be looking at?
Well, I think in the space industry it's quite interesting. There's two elements to it. There's the how do we manufacture satellites, and we have to manufacture thousands of satellites over the next 5-10 years. But there's a reluctance there of, well, we've never used this kind of technology before, and this is very similar to mainstream manufacturing, if you like, of this. I'm not sure what it is, I don't really know. I've always made it this way, so I'm not going to change it. And it's that cultural thing that's a few people, Folly and Steve have already mentioned, of this, if it isn't broke, I'm not going to fix it. But even when we're talking about robots in orbit or on planet, there's still this kind of conservatism around the technology. It's got to work. If we send a robot to Mars, it's got to work because it's a very long way away. We can't call a service engineer and expect them to be there in 24 hours as BMW might be able to do. It's just not going to happen. So we've got to be pretty sure it's going to work. But there is this really almost an understanding that we need to use robots in the space industry, in orbit, on planet, but then a kind of conservatism around what the technology is and how we do it. And so we do go through lots of risk profiling. You're right, but it's a cultural thing. I think that's the nub of it. And certainly the last 25 years when I've been trying to help manufacturers use robots, it's that culture of getting past this, well, we've always done it this way, so why would I change? And if you can get past that, then people start to open up and realise the power and the benefit that you can have with robotics, even if in the very beginning there's kind of this understanding of this is something I've got to do.
No, thank you. And so culture is obviously an important aspect, but I also believe skills is one of the major issues that we face, and maybe just move on to that for a second or two. But sort of Ben, going back to you, in terms of your business, where do you find the people? Where do you find the skills to take the technology forward to develop what your customers actually want?
So that they're often not UK. They're not from the UK originally. We've got a CTO who's Brazilian. The head of robotics at my parent company is French. Our best software engineer is South African. So they're harder to find in the UK. Why that is sort of well, presumably on an education thing, and there's just people not going into these industries as much as in other countries maybe. But yeah, it's definitely a problem that we've thankfully people are available. It's cosmopolitan. This is a cosmopolitan area. There's people that can come from. We can employ people from around the world, and we're open to that. But for the UK's like bedrock pool of labour developing robotics, I think we are short, especially if we are going to be shifting to increasing robotics, roboticised economy.
Yeah, and Volley, do you see the same kind of issue both in terms of your business, but also your customers in terms of, you know, are they struggling to find the people, the skills that are needed to, in your case, to deliver the solutions, but also for the customers to actually use them?
So, firstly, I do agree with Ben. There's shortage of skills, but that's, I think, general across engineering. It's not restricted to robots. UK has a problem with engineering talent. But having said that, we haven't had a problem finding people. And to put it honestly, LinkedIn is the best source. The moment we upload or publish a job, even for a small company like ours, we end up getting 100 applicants and more. So finding people has not been the problem. I think the acceptance in our company particularly of the fact that we're not employing people with 20 years of experience, but we're employing somebody who is fresh out of university, but that person has the willingness to learn and grow, and the willingness to accept things that they don't know, but accept the things that they want to learn, and they have to learn a lot of stuff in a very short period of time. So that's the acceptance from our end that we have to do, and finding people has not been a problem. Actually, there's been a huge advantage for us, the fact that our whole team is fresh. Because if we need experience, there are many people in this country who are experienced. We can liaise with them when we need the experience. But at this point in time, we need the willingness to go the extra mile more than anything, and I think we get that with fresh graduates. On the other hand, I think it's also a mentality of end users to employ the right kind of people, and it's always a question, right? So who is the right kind of person? And it's a change of mindset now to think, okay, well, if somebody doesn't have a graduate degree who's not done a master's, is that a big problem? So how do you actually employ people? That is changing. We see that changing with end users. We see that changing with manufacturing companies. I think everybody is moving towards the direction of encouraging to hire graduates, and it's okay if the person doesn't have the experience, but you give them the platform to learn, give them the opportunities to learn, and put them in challenging situations if they're willing to take it. So we've learned it. Our theory of learning is just learning by doing. We fail, we do it again, we learn. We don't go on expensive training courses. That's just how we do it. We don't go on expensive training courses. We'll probably just buy a lot of stuff that we want to play with, figure out how it works, fail, and then figure out how it works again. And that's just how we go about it. But we haven't found it to be a problem to find people. That's not been our from our end. It's not been a problem.
Okay.
Yeah, I'd agree with that. It's just more about like where the people are they coming from are they like from the UK, or are they?
No, most of them are not, and hence I agreed with you initially.
I agree with everything you've said. The approach is exactly like.
Yeah, so they've not been in the UK, but I do also believe in today's day and age we have to kind of close our eyes on where the talent comes from, as long as the talent comes. At the end of the day, what we're aiming to do is take our work forwards by representing our company in the UK, and that's what matters. You know, where the talent comes from.
Yeah.
As long as it comes.
Yeah. Fair enough.
It continues to come.
Steve, I mean, from your perspective, you've been on the journey, so...
Yeah, I think Valley's got a much more exciting company than us.
But you must have changed your profile in terms of employee.
We have, and it's been a massive learning curve for all the individuals involved. And like Valley, you know, a lot of it's been self-taught. We've just had robots and we played with them and thought, oh, we can do this and do that. And the talent grows. But when you're in industry and you're trying to service customers and you're trying to change quickly, you don't always have the time to just, you know, train people internally. Most of our guys are self-grown. That's how it's kind of about. But there's now and again we just need some people in. We need some resource. We need some experts. And to go out and hire an expert in this field is very, very difficult in our view. You know, LinkedIn aside, you know, these are people who have to come in, hit the ground running. I apologise to anyone here who's in the education fraternity. You know, I've got 3 teenage children who've just been through school. One of them's now an apprentice with us, and they've been down the science route. And you sit there and you go through the homework and stuff. And my one conclusion is we're teaching them the wrong stuff. We really, really are. We are 10 years behind where industry is at, what we're teaching our children. And that's my honest view, is that I think the mass of our education system has failed to keep up with where the technology's gone. That's my honest view. And for anyone in education, I apologise for saying that, but that's kind of what we see. And I think for us as a country, and yes, we can hire from outside. Nearly every engineer I have is not UK, doesn't come from the UK. You know, we've got Poles, we've even got Hungarians. You know, they've got the skills. They came in, they've got the skills, you know. And my view is I'd just love to see our education fraternity engage better with industry, understand where we're going, understand what we need to do within industry, and sort of let it flow the other way. I've seen you know, we work quite a bit with the Abingdon Whitney College. They seem to have got it, but where I come from, where I live in Gloucestershire, they haven't got it. Not a clue, in my view. So I think I'd just love to see that sort of, if we can tie the two back together again. You know, there's a wealth of talent and talented individuals out there, and you know, Valley's absolutely right. You get someone with bags of enthusiasm straight out of university, and they tend to roll on pretty quick, and that's where I'd have said most of our talent has come. But when you're trying to run a factory and you need individuals, you know, that've got those skills, they're not learning them in the education side, they're learning them in this industry, and that's the only place you can go for them, really. Yeah.
No, thank you, Steve. Jeremy, any views on that? Do you excite people into space robotics?
Well, I'd actually just echo what Steve's saying. I'm apologise if you're an educator, but there's too much of chalk and board education. There's too much learning equations and mathematics and kinematics and all this kind of stuff. It's important, but what's really important is that aptitude. And Volley's and Steve have mentioned it. It's that and Ben, it's that aptitude to get on with the job, to learn quickly, to not expect to know all the answers, but to fail really fast. And that's what we need in the space industry. We've got to move really quickly in the space industry. We don't know what we don't know right now. And so we've got to fail fast. We've got to learn how to do these things. We've got to learn how to take an ABB robot, put it into space, and make another satellite out of it. You know, we're not going to send the ABB robot, so we've got to figure out what that looks like. We don't know what it looks like. It's that aptitude of saying, I've got to do something. I don't know how I'm going to do it, but come back next week and I'll tell you how I think I'm going to do it. That's the attitude that we need in the industry as a whole across all robotics.
Fair enough. I suppose at this point, I'd just ask if anybody in the audience has got a question, please.
Is one of the problems that there's no British robotics manufacturers? You mentioned ABB. I looked through the brochure today. I see German robots. I see Japanese robots. If there were more robotic companies in the UK making their own equipment, then you would get a supply of people that have done the playing around with the robots in the first instance, and then they move from the manufacturer to manufacturers.
Anybody fancy answering that?
Yeah, well, I'd say that there are lots of UK robot manufacturers. They're just not the robots that you might see in a car factory. And there are lots and lots of smaller robot manufacturers, including Ben and including some others around, who do really good stuff in markets that are not mainstream. We are not going to have a KUKA or an ABB or a Fanuc, whoever it might be. That's a huge amount of investment. Those companies took 50 years to get to where they are in size. We need to be realistic and say that's not going to be us. We need to look at the other market areas and say, what are we good at? Where have we got really good potential companies that we can grow, we can support, and we can scale And it's something that UKRI have realised, and they're starting to look at how do they find these companies, how do they nurture them, how do they develop them, how do we develop the testing, proving grounds to help them out and commercialise. And so I think over the next year or so you'll see quite a lot come out of government and UKRI in supporting those kind of organisations. I would strongly contest that we have some very, very good, some world-leading robotic companies in this country. They're just not manufacturing robots. They do other things.
And I think it's also worth adding that even with the industrial robots, the robot itself is just a tool, if you like. It's the system that you build around it is what makes it actually do something. And we have some very, very good systems integrators in the UK. So we have an awful lot of robotic expertise. Whether we've got enough is something else. Volley, I don't know if you've got a view on that.
I certainly feel it is not necessary to reinvent the wheel. Robots exist. They've existed for many years. Robot brands exist, robot manufacturers exist. We don't need to necessarily make robots. We need to be the fastest adopter of robots. So, which means that if we buy a robot from Denmark or we buy a robot from Germany, it's okay. As long as the rate of deployment of robots is faster in this country as compared to the rest of Europe. That's what's important. But making robots here is not going to change that. What will change that is only the synergy between the end user and the service provider to be stronger. But if KUKA made robots here in the UK as opposed to Germany, that wouldn't have changed the total number of robots being used in the UK. Because that's essentially a robot is out of the box, just a robot, where, as Mike said, where the value comes is the actual solution itself. And we just need to be faster in doing that.
We had a question from the back.
Yeah, hello, John Henderson from Sarah Penrose Limited. Question for Steve, actually. Just in terms of the process you went through, what was the impact on, two questions really, what was the impact on headcount, and what's that actually done for the roles in the business? How's that worked out?
It's a great question, actually, because if you talk to a local politician about robotics, he goes white as a sheet and thinks that's the end of his electorate. The actual honest truth is the total opposite. So as we've automated, what we've actually done is we've just increased our output. So the people who were traditionally just doing all those repetitive tasks are now doing more, higher skilled tasks. So our headcount has gone up, not down, considerably. People have become salesmen, technicians, you name it, quality technicians, anything but just sitting there on a production line putting things together. Yeah, so we've now grown, our headcount, when we first put our robot in, first robot went in, our headcount was probably 200. Today I think it's 450. Our sales have grown from 20 million to 100 million. So it's been a very, very rapid growth, and what the automation has allowed us to do is to service our customer better. And it's as simple as that. When they pick up the phone and they want their pink helmet with blue spots, it's a 5-day turnaround, not a 6-month slow boat from China. And that's what we do, and we do it every day. So we've used the automation to make ourselves agile, lean, mass customization at a level no one could ever dream of. And that's the reality. So yeah, when someone says, ooh, that's my job gone. No, it's not. That's an opportunity for you to do something much more worthwhile for the business.
It's a similar experience from logistics, because I've worked in logistics for a number of years. Yeah. Same thing. People are saying the same. Automation's come in. People are going to more value-adding, customer-focused roles rather than being on the shop floor, as it were, or more value-add VAS services. So similar experience.
Absolutely. Yeah.
Can I just add that whole conversation there, that little conversation, is only something that would happen in the UK. That you wouldn't have that conversation in Germany. In Germany and the rest of Europe, Korea, even in the US, it would be a case of, no, this is going to create value, this is going to create new jobs, this is what we have to do. It only seems to be in this country that we go, oh, they're going to take jobs. And I guess that comes back to our culture again.
And maybe just to add another point on that, but perhaps surprisingly, but the unions themselves are not opposed to the use of robots. Very much the opposite is true. They want a fair share of the reward from using the automation, but they very much buy into the fact that automation leads to productivity, leads to growth, and so on. Claire, you had a
Sorry,
question.
if I can just add into this one, just 2 minutes.
Yeah.
Trust me. Yeah. And this it goes back to the original point when I was talking about the accountants and value for money and if you put a robot in, it's got to pay for itself and it's got to do this. It is the biggest load of nonsense. Trust me. Yeah, I've been there. What the robot does is allows you to grow your company. It allows you to make better products, faster, better service for your customer. So if you just look at it as, well, I'm doing this job and I'll put a robot in there and that person costs X and the robot's going to cost Y and the sums compute. That's not what it does. It really is not what it does. What it does is allows you to be more agile. Those people go into much higher skilled jobs, and you'll find as a business your growth will accelerate dramatically because of what you're capable of doing for your customer that no one else can do. So never go into a robotic project or any sort of project with automation which is just focused on how much money can I save. It's not. How much money can I make? Yeah? Okay, that was my point.
Thank you, Steve.
So, Ben, I just wanted to say to you that you said you're not sure what nuclear's got to do with manufacturing.
Oh, no,
To me, dismantling is just construction in reverse.
Exactly. Well,
and within MTC, we do an awful lot of work in construction.
Yeah.
It's about applying the manufacturing methodologies, tools and techniques to something that possibly seems at first sight not to be related. And please have a look at if you haven't already, the toothbrush circular economy thing next door. I think there's some opportunity in there for nuclear and for construction with that. Bit of imagination required. Am I allowed another quick one as well? So
You're making points.
I am making points. Right? I know. And my second one is a point. I beg your pardon, but I think it's relevant. So I can't hide my age, so I might as well embrace it. Back in the 80s, there was a comedy sketch show. Can't remember which one it was, but a guy walks into a factory. Goes, "Hi, Bob. How are you? Bob, you all right? How are you, Bob?" And the end of it, the strapline was built by British manufacturing, built by Roberts.
Yes.
That was in the 80s, for goodness sake. We've not got far. Can I add a question? Why not?
No, do you want a seat?
that was, it's not the 9 o'clock news for those that are old enough to remember that.
I do remember it.
And it was at the same time that the Fiat Strada ad was out, where they had cars hand-built by robots, and whereas British Leyland were hand-built by robots.
Built by robots driven by Italians, wasn't it?
It was, yeah. But one of the unfortunate consequences, if you like, of what we've been doing is that UK manufacturing is a long way behind what the rest of Europe and the rest of the world is doing. And if we want UK manufacturing to be productive, to be competitive, we need to find a way of changing that. So I just want to ask the panel very quickly, what do you think we could do to make a change? Steve, do you want to go first?
Oh God, now you've lit the blue touch paper. So, for us as a business, we just had a recent foray. About 3-4 years ago, we opened up a factory in Germany because we've done very well in the UK and we've almost sort of saturated our UK market. Our main growth was in Europe. My belief and our belief as a business is you need to be close to your customer. And when you're at that arm's length and it's very difficult to service them, and one of our best selling tools is actually our factory itself. I'll say that. You get a customer in, he sees an automated factory with all this stuff whirring around, something he never expected. It's a selling tool in its own right. So we opened up in Germany. And, before we know it, we put in our first few automated helmet cells, and people start walking through the door throwing money at us, literally throwing money at us, saying, "Oh, you're doing this, and if it's energy efficient, I'll pay for half of that." And then another government official comes in and says, "Oh, this is good for our economy. If you do that, here, have a load of money." The 20 odd million we put in there, I reckon 10 million we've had in grant. UK, 0, zip, nothing. I don't understand. I just don't get it why. And and the Germans are not, don't get me wrong, the Germans are not as efficient and as wonderful as they make out, but they are realistic. They understand that if a company is investing in their economy and in their local community, they want to be part of that. And the better hand up you get and the faster you do it, You do your calculation, they get the money back in tax in 5 years. Yeah? So what's wrong with our lot? I don't get it. I just don't get it. Why is our own government, why can we not lobby our own government to just see the wood for the trees and say, hang on, if you give particularly smaller companies like ours, well, we were small in the day, but we're getting better at it these days. But you know, for these young entrepreneurs, if there was some kind of leg up in that process, the government's going to get their money back. Why does it not exist? That's for me, you know. So,
Ben, any views?
So that kind of culture, finance shift. Completely agree with Steve, but also the sort of siloization in the economy. There's like things that there's so much things in agritech, in nuclear, in water treatment that could be robotics that have been developed in different sectors that can be applicable in other sectors. But just being able to help develop more of a collaborative community and more interdisciplinarity between different sectors.
It's just not joined up, is it?
Yeah, there's lots of different. I think it is it's a culture issue.
It just boggles me. You know, I've come across so many politicians and so many civil servants, and they're just not interested. Doesn't even compute on their scale. Yeah.
How about you, Volley?
So before I give my feedback, I just want to put a number out there. So just take a new industry, for example, like the drone delivery service that we spoke about. I was surprised to know the delivery service in the UK as a market is 5 times bigger than Europe combined. It sounds bonkers, but that's true. So when you think of an industry like that, that obviously means it's an opportunity. And the only way to seize that opportunity is to be fast with what you do with it. And I think the only takeaway personally from personal experience, what I would say the only way to change this trend with manufacturing is take a risk, however small that is. Just take a risk and do it. Because until you do, you don't know what the answer is. And that's just fact.
Thank you. Jeremy, what do you think?
I'm going to agree with what everybody else has said. I think it's, take the risk, be prepared to fail. Don't live in your silo thinking you're a nuclear robot or a space robot or a manufacturing robot or a logistics robot provider. You're a robot provider. You're a robot company. And if you're doing something that's really interesting in logistics, it might be that somebody somewhere else is going to find that really interesting. So have those conversations, work together. And then I think there is a big role that government has to play in this. You get into the kind of realms of big government, which nobody likes, but government has the convening power to pull people together, and we've been talking about that in the robotics industry. Well, for as long as you and I have known each other, Mike, and we haven't achieved it yet. We need to break this barrier of saying, just because you're doing that doesn't mean you can't talk to those people, and actually government are the people who can bring everyone together.
So maybe just to try and bring this together into some form of conclusion at least. I think we're calling for more government support for manufacturing in general.
I think it's just that risk thing. It keeps coming back to, the risk thing is, yes, we all take big, when we do this, we take big risks. If there was someone behind you who was saying, because when you're umming and ahhing and then you've got that helping hand, it makes that decision just that little bit easier to say, okay, the risk isn't 100% mine now. It's not my house and everything else. There's someone behind who actually believes in what we're doing.
Yeah.
It just disappoints me that, our experiences in Europe are so different to what we experience here in terms of how as manufacturers we're perceived, and the help that's out there to give. And I just can't help thinking if there was just a little bit, rather than letting everyone just paddle their own canoe and they're on their own, and if they fail, they fail. Oh, tough luck. There's actually someone, and not only that, within those European countries, there's also a reasonable infrastructure to help. If you don't know what you're doing, they'll put you in touch with someone who does. It doesn't happen here. It really doesn't.
Do you think it's sort of connected to just the government was put off picking winners, and now they don't pick any winners?
Yeah, kind of thing. Yeah,
it's sort of there.
Yeah, they're so scared of picking a duffer that they don't pick nothing at all now. Yeah.
So sorry guys, I'm going to have to wrap this up because I know we're up to the end of our time. But just So we're asking for more support or recognition from government, definitely. But I think the other point that's important in all of this is finding a way of more collaboration, more cooperation between all the different sectors, so that we can all learn from each other and if you like, share the failures, so that we don't make the same mistakes in each sector, and make the best of what we've got. We do believe, and those in the industry know, that we have a strong robotics sector. It's just unfortunately not one coherent whole, and we need to find a way of bringing it all together so that people can see how strong it is, and we can all work together to solve all the problems that we do all face. So I'd like to thank each member of our panel for their contribution. I hope you found it interesting and informative, and if anybody's got any other questions they'd like to ask each of us, I'm sure we'd be happy to answer them once we've got off the stage. So thank you very much for your attention.
I'm absolutely loath to bring that discussion to an end. It was a really lively discussion, and as Mike says, I think it could have gone on for hours. We're now going to, so thank you very much, gentlemen, if you'd like to leave the stage. So the last, we heard actually within that session about sourcing talent with the skills needed to kind of hit the ground running. Well, you'll be very pleased to hear the last two sessions are addressing just that. So we are focusing on the future of skills required actually within the engineering and manufacturing sectors. Before we discuss this, I've asked two of the apprentices currently at the Oxford Advanced Skills to give their story and to tell us a little bit about why they chose an apprenticeship route, what they wanted to get out of it, and what they're looking for in the future. What I've also done, and I'm not sure I've told you, Anna, this yet, is I've asked them to think about a question for the skills panel. So if you can think about that then, guys, and we'll put that to the panel. So if I can have Max Butcher up first. Thank you.
Hi there, thank you. So my name's Max Butcher. Yeah, I'm a level 3 electronics engineer with STFC, based here on site. Currently working with the diagnostics team in ISIS, which is our particle accelerator. Yeah, so as an apprentice, obviously I've only been working for 14 roughly months, for the first year of which I spent with OAS down in Culham, and through there I've learned lots of skills and been able to develop lots of skills. Said that twice. So I've spent, so my entire life I've been interested in engineering. My childhood dream was to become an inventor, which, granted, I'm not sure I entirely understood what involved, but I stuck at it anyway. So I spent all of my childhood building things, working with things, mainly working at cardboard, but obviously I'm improving now. When it came to picking my GCSEs, obviously my first choice was engineering. When the slots at college, at the engineering college down the road for me opened up, I jumped at them. When it came time to pick my A-levels, it was front of the line with my selection, engineering. So as for my experience in engineering, obviously spent the first year at OAS, in which they taught me lots of skills that I hadn't already got from my engineering qualifications at school, such as a lot of the millwork and hand fitting stuff that you can see there, and so I've spent a lot of time, roughly now, in 5+ years, roughly, in my 19-year long life in engineering, which, it doesn't make me an expert, obviously, but I do what I can, and I'm doing my very best to advance myself in the way that I want to. So when I had finished all of my qualifications, I had ended up with the same question that most people have: do I go to university or no? And obviously, I realise a lot of you probably have experience with hiring engineering staff and may disagree with me here. But from the engineers that I had worked with and spoken to and my own personal experience, I decided that my time was more valuable than any degree, especially given the fact that a hiring company would pay for me to do the same degree in a couple extra years, and I would have 4 or 5 years of experience on top of people that didn't. And so I chose to do that. That then obviously led me to OAS, and I keep going off working with my team at ISIS. And so I continue to develop myself as much as I can, trying to become almost the forefront of my department if I can. I want to be the best, and for that I keep taking every opportunity I can. So I've done things like I'm applying to become a health and safety first aider. I join all of our company webinars. I network with everyone I possibly can. Even at OAS, when I got the chance, I made a bunch of stuff on our lathes. I've made a couple of titanium rings. I made a lightsaber and things. It's because I had the opportunity and I thought, this is a fun way to develop myself and to show off a little bit. And so that's what I did. I even further that, and I even entered our company bake-off, which I might point out I made to the final of. But yeah, so I continue to develop myself as much as I can, and I don't know where that's going to lead me in my future. But yeah, I'm fairly well versed now because of my apprenticeship. Because I've had, through my apprenticeship, I'm going to have many different teachers, many different trainers, and hopefully that should give me a vast perspective on the different aspects of the work so that I can continue to develop and think outside the box that university-trained people may not even think of. That's my hope. As for where I end up in the future, I don't know yet, which is exciting, if nothing else, because I'm working, obviously, with a lot of different departments, which should give me a well-versed experience in lots of different places in which I should hopefully be able to develop myself. If my hope at the moment is realised, that would be in space. But that's where my interest lies, and I won't talk too much about that because I know Cameron's going to cover that as he's a space apprentice. But that is my current interest, and that's where I'm targeting at the moment. And so, yeah, thank you. And if I can just question the panel quickly, yes, given obviously how quickly the engineering departments and sectors are growing and how many people there are out there, young people, so with obviously very hard-working and developed individuals, apprentices, and how are you intending to further influence and recruit those people into your departments? Thank you.
Okay, so Cameron, do you want to come up from Oxford Space Systems?
Let's get that. I don't have any fancy slides, unfortunately. So I think it's afternoon now, so good afternoon. I've just been introduced. I'm Cameron. I'm not an electronics engineer. I am a manufacturing, assembly, integration and test engineer. I work for Oxford Space Systems just down the road. I'm going to talk to you a little bit about my experiences throughout my apprenticeship and kind of what it's like to be an apprentice here. So prior to beginning my apprenticeship, I did my GCSEs. I did them down the road in Didcot. Moved on to my A-levels, and throughout all of that, I thought, I want to go to uni. I want to do standard thing, go to university, get a degree, get a job in engineering, until it came time to apply. And I thought, at this point in my life, I think the experience is going to be far, far more beneficial to me. So I had a look around, and I found Oxford Space Systems here. So I applied for them, went through the entire application process, and jumped at the opportunity for that job when it was offered. At that point, went off to Oxfordshire Advanced Skills, much like Max did. I started that in 2019, and as of 2-3 weeks ago, I've just started my Higher National Certificate as well, which I should be finished, hopefully, in 2 years' time. So my experience being an apprentice, especially in the space sector, I think it's hard, but it's incredibly rewarding. I didn't really think I don't think I really came with any ideas this is going to be easy. I kind of knew it was going to be difficult, but it's in different ways. I spent the first year at Oxford Space Systems, OAS, doing much the same that Max has talked about. I then went to my job, and I have become far more knowledgeable in far more than I thought I could. So I've had to do work in composites, I've had to do work with inspections, making sure that everything's clean before we assemble it, and then actually assembling it as to a process. All of this is stuff that I don't think I'd have learnt at university to the degree that I'd have needed. That in contact with the continuous support from OAS, from MTC as well, who are very excellently put this on today. I think it's been really good, and with the potential for, see, I've lost my notes now at this point. Get rid of it. Yeah, I think with the growth that we're going to see in the industry and the amount of apprentices that we have the opportunity to bring in, I think it's a really, really good time to be an apprentice. And yeah, I think at that point, see, my mind's gone blank. I thought I had more to say. Anyway, yeah. So I do have a question as well for the Future Skills panel, and it kind of goes off of Max's as well. So Max has asked how we're going to potentially bring in more apprentices. I see, as we grow in all of these industries, the amount of technical knowledge, I think, is going to increase. So how are we also going to support the apprentices through these potentially more technically challenging industries? So robotics in space, in nuclear down at Culham. So how are we going to be able to both incorporate more apprentices, but also bring them up to the skills that could be progressing very, very quickly, very, very soon? I think that's it. Thank you.
So I shall let you into a little secret. I nicked the idea about having some apprentices speaking to us. We had our leadership conference, internal leadership conference at the MTC a few weeks ago, and we were talking about wise and sage things and doing plenary feedbacks and thinking we were really good. And then we had a couple of our apprentices actually talk to us, and they absolutely blew us apart in terms of their thinking and their clarity. Thank you both, Max and Cameron. That was excellent, and to hear it directly from you, I really, really appreciate that. So we're now moving on to the Future Skills panel. I've tried to capture those two questions for Joanna. So how are you intending on attracting new young people into the sectors? With technologies actually changing at such a rapid rate, how are you going to make sure that they're actually skilled to do so? So if I can ask the panel to join us at the front here. Okay. Right, Joanna.
Excellent. Well, everybody sits down. I think we're going to have a really exciting panel session. It's been brilliantly teed up. We started off with Claire this morning saying that this is all about conversation. As with the last two panel sessions, have really got us talking. There's been lots of discussion, almost debate. Let's see if we can carry that on. And my challenge is to get a debate, because I think that's when we come up with the best solutions. We were hearing all about engineering and how that's about solving problems. How do we solve these problems? How do we get more amazing people like Max and Cameron coming through and actually being here to help us with the problems in the future? Anyway, just first of all, I ought to introduce myself, and then I'll hand on to the panellists to introduce themselves, and then we'll get into the real meat of that debate. So as mentioned by Barbara earlier, I am the Harwell Space Cluster Development Manager. My role is to help grow the Harwell Space Cluster, both by attracting more companies here, but also by helping those that are here to grow. And one of the key challenges that those companies have had, and it's been picked up today, is skills. How do they access those skills? And so what I've been doing over the last couple of years within STFC is looking at basically how can we have more Max and Camerons? How can we have more of those apprentices coming through, not just apprentices, but graduates, people that are returning and reskilling. And I've put together a skills factory proposal. Still trying to get the funding for it. If anybody's got any ideas, then let me know. But, about how we can really increase the number of people coming through and make sure that they're actually feeding directly out into the SMEs, that trained workforce through. I think the other point to just make very quickly is I've been trying to get a Harwell Space Cluster cohort of level 4 space engineering apprentices together. If anybody is here and interested, let me know, because it would be great to have more apprentices coming through and be able to share them around Harwell Space Cluster. And that was mentioned in one of the earlier talks about that ability of bringing skills together and being able to share people. So do talk to me afterwards if you're interested in that. But without further ado, let's hand over to our fantastic panel today. Kathy Bowden, if you could introduce yourself, and then we'll work through everyone, and then we'll go on to the questions.
Hi, as Joanna says, I'm Kathy Bowden. I'm the skills lead for the Space Agency, which means that I'm working across the sector with organisations from those who are building and launching pieces of kit to those who are using the data from space to deliver products and services. I am working my socks off to try and make sure that everybody can find the skills that they need. I really recognise the issues that everybody faces, and to that end we published a skills report this year, and allied with that we've supported the delivery of a bunch of reports around the demographics across the sector. So we know we've got benchmarks, we need to do something about it. And like Joanna, I'm waiting for the outcome of the CSR as to whether or not we can move forward on some more expensive opportunities for upskilling and reskilling. But also we're developing some ideas that actually don't have a price tag associated with them formally, but should be useful to more people as well. So,
excellent. Thanks very much. David, over to you.
Yes, so hi, David Martin. I'm ex lots of things. I'll start at the start of my career. I was an apprentice. I'm an ex-apprentice. At the end of my career, I was the COO of UKAEA. So anybody in apprentices that might listen to this, the sky really is the limit. So yeah, I ended up as COO. I now run a programme trying to build apprentice training hubs across the UK to deliver apprentices from level 3 up to level 7 across various sectors, space being one of them, power engineering, nuclear, robotics, and energy storage being the others. So yeah, that's me. I'm also on the Oxford Skills Board. So if there are sort of questions around sort of global Oxfordshire skills, I may be able to answer those. If not, I'll signpost you to the person that can.
Excellent. And then in a very Blue Peter fashion, we've had 2 apprentices, and now I'll hand on to this is what happens when you get to the end product. Over to you, Rob.
Yes, so my name is Rob. Just hello. Yeah, so I've got a couple of years on Cameron. So I've actually been through the apprentice scheme that OSS has been running. And yeah, so I'm a fully qualified technician working for the company. A quick note about Oxford Space Systems is it's a very, very new company. Started back in, I think, 2013. I think somebody's going to slap me at the end. But it started off with about 7 people with an idea to build deployable space structures, whether that be antennas, booms and various other different structures. If it starts small and turns out into something big when it's in orbit, that's essentially what Oxford Space Systems is trying to achieve. And any time that you think of, oh, I want something like that, you want to think of Oxford Space Systems. That's our kind of end goal. In about 2018, I'm thinking, geez, it makes me feel really old now, the company made a decision that they needed more trained technicians, and at that point they made a decision to sort of home grow them with the apprentice scheme. So they actually launched an apprentice scheme. To the description that I was given was that some people come through with what they call baggage, as what they like to describe it. So people had sort of 30 years of experience, and they only needed somebody who had about 5 to 10 years worth of experience to then carry them forward. So that's why they started the apprentice scheme, so they could train people to do very, very specific tasks for what they needed them to do, not have all of this other experience that was not necessarily needed. So that's how I came into it. So originally I did my GCSEs just like any other normal person at this time, and after that I didn't know what I wanted to do. I had a vague idea that I wanted to be in some kind of engineering sort of area. I like doing things with my hands. I like learning on the job and stuff like that, but I didn't really know exactly how I was going to get there. So I took a 2-year break, and I worked. I did a college course in engineering for 2 years, and then by the end of that, by the way, that was at the UTC Oxfordshire, if anybody was curious. Yeah, and then after that, I applied to Oxford Space Systems as well, and then luckily they took me on for their scheme, and 4 years down the line, here I am now.
Brilliant. Well, 2013, you were absolutely right. It actually got its first funding from the coffee shop over the road, where there was a chance meeting between the original founder and the person that was potentially funding. And that's what's interesting about these ecosystems. Not only do they bring the skills together, but they bring the funders together with people with ideas. And I think that's what's exciting about these sorts of discussions as well, bringing all those people together. Although the fact that 2018 makes you feel old, just have a thought. Right, let's move on. Yeah. So we've got two real tough questions to kick us off. You can always rely on the apprentices to give us those. So how are we going to create more apprenticeships? And also, well, let's do that one first. Over to Kathy to start that.
Well, firstly, of course, we need more companies to step forward and say that they're interested in taking more apprentices. That's a good part. The other one, I think, is looking at the landscape and the offering and the standards for apprenticeships that are available for companies to utilise. And undoubtedly there are some that are fairly generic, that can be used, that can grow into other things. But I talk to quite a lot of people who say, well, I can't see how I can make it work. It's too difficult, and I don't see the standards I want. So there's a piece there to be done as well. I've got the scars to prove it with the space engineering level 4. It would be nice to feel that we'll have the level 6 approved before the year end. I'm beginning to feel as if I've said that rather a lot of times, though. So I think, it's got to come from both sides of this.
So I have a PhD in particle physics, and I have to say, understanding apprenticeships, all the different pathways and all the different elements underneath, it is not straightforward. So David, how do we make it easier for companies to engage in apprenticeships, and how can OAS help people on that?
Easier. Okay, so I come from the world of apprenticeships. I think it's reasonably easy now. Maybe I need a PhD. So, to make it easier, I think companies need to come to the realisation that the way to solve their skills gap is make a decision very early. Don't wait until it's a problem. If you wait until you have a skills problem, then you either have to go and steal someone else's skills, or you cook your own apprentices, and that takes 4 years. So you need to get involved early. So even if you don't think you need apprentices now, but you think, well, maybe down the road be a good thing, get involved now. There's the levy funding. If you're a significant employer, there's levy funding available, which is at the end your money, but if you don't spend it, then it's taxed and somebody else will. Or if you're an SME, there's levy transfer, and I know MTC have this levy transfer proposal in place from Lloyds, I believe it is, where they can transfer Lloyds money to train apprentices for you. So the training costs you absolutely nothing. You're not paying the levy, you're using Lloyds levy. That's sort of a no-brainer, really. You get these people trained for free. If you look at the other thing, make it easy. If you look at the loyalty from those who train as apprentices compared to graduates, you'll find that because the apprentice has been nurtured in the company, they come to OAS for a year, but then they go back to their company for 3 years. They're nurtured in the company, they get used to working in the company. They tend to be more loyal than graduates. I could give you the numbers for UKAA, but it was between 2 and 5 years graduates got itchy feet and away they went. Apprentices, I think the retention rate is still over 80% at Cullen for apprentices since we started in 2005, restarted in 2005. So OAS will make it as simple as you wish. If you want to talk to the people from OAS, some of them are sat down there. It is something really easy to get involved with. It's very rewarding. Your apprentices will fast become your sort of go-to people for solving technical problems. You're very lucky in the space sector that you don't have this baggage that other sectors carry. And I say that in a serious way. I wasn't just playing on your words. That the more traditional sectors do carry baggage, and the apprentice used to be someone that did 6 years filing washers until they finally were trusted to make their own washers, that sort of stuff. It's not like that anymore. It's completely different. So that's it.
So I think one of the important things is for companies to realise just how much value apprentices can deliver from really quite early on in their career. perhaps, Rob, you could say something about how quickly you could actually feel you were helping at Oxford Space Systems.
Yeah, so one of the common misconceptions I feel with apprenticeships is that we are not like the previous panel of like hiring robots. We need to have a certain amount of time to learn. Yes, if you stick us in a training site for a year, we will have the basic knowledge that we need to do what the training provider has told us to do. But how do we then transfer that knowledge that we've then been given to when we are actually spending the rest of our apprenticeship at our company? And that really comes from support. So back to the original question of how do we get more companies doing apprenticeships, I think companies do not understand exactly the cost of hiring an apprentice. And the companies can't just put them into a training provider, and then next thing you know, you've got like an amazing technician that can do exactly what you want and read minds. It doesn't work like that. You need to have that ongoing support through the whole duration of the apprenticeship to then get who you want. And then to answer your question, I was useful at about year 3.
Okay. But since then, you've been very useful.
Yes.
Clearly, they've offered you a job.
Yes. Yes.
Excellent. Now, one of the second question that came from Cameron was we're going to have to know so many more things. There's lots of new technology coming through all the time. So how do we manage this? Is it a case of we've just got to keep expanding the education courses? We heard earlier that perhaps schools are 10 years behind where they should be. Is it about them changing their content? Do we need to keep adding on more content into all of our training schemes? Or is it more about the fundamental skills underneath and then how quickly you can put those additional skills on top? Over to our panel. Let's start with David this time.
Thank you. Very good question. I think you can change the education system a million times a week and you'd never get it right for everyone. The education system has to be something very generic because it plays into a load of different industries. So as long as, from an apprenticeship point of view, people have English, maths and science, the rest doesn't matter. As long as they come in with those fundamental GCSEs, the rest we can teach them. What we actually teach them in OAS is the fundamental stuff. We teach them how to be work ready. So they're not, they're not schoolboys coming in or schoolgirls. They're actually sort of ready-made technicians to come into the workplace. They know how to behave. They know about timekeeping, all that good stuff. And we teach them fundamental skills. But what they also learn is how to solve problems, and that's a huge asset. So this young person will come in. They've got from the education system. They've got what they've got from OES. They've got what we've given them. They then come to your company. And you are the ones which have to input that last bit of superpower in order that they're the wonderful technician you need. You're the only ones that know exactly which quirky part of engineering or robotics or whatever it is your company needs in order to thrive. You could come to OAS and say, could you teach them that? And then we'd be teaching thousands of people, thousands of things. It just doesn't work. So what you need to do is you need to invest in the person, get them work ready, get them learning ready, and then put them in the workplace. And I think then they start on their journey of learning forever. It never stops. You go through your whole career still learning. And I guess even as you retire, you still learn some stuff there. You never stop learning. So I heard it earlier, take every opportunity you can to learn something. The other good trick is to link up with someone like MTC, who have a weather eye on future technology, manufacturing technology particularly. So if you're busy, making what you make in your company, doing what you do, maybe you're not the one who's out there at conferences and that sort of stuff, seeing what new technologies around the corner. Link in with MTC or one of the catapults and understand, get them to help you to understand what's down the road and what skills are needed.
Kathy, do you have any views?
I do. I'm going to build on what you've just said. Because one of the things we've been working with the Satellite Applications Catapult, but also with the High Value Manufacturing Catapult, is how we can do a piece, basically do a regular foresighting piece on what skills we're going to need going forwards. You know, I go and talk to companies and they can, you know, frequently they can vocalize exactly what they need now. Can they vocalize what they're going to need in 5 years' time? Possibly. Can they vocalize about 10? No. And if you think about the lifespan of developing that apprentice, we need to be thinking about that kind of time frame. So we've got an initiative going forward, as I say, with both the catapults, to look at how we can pull people from across the space sector particularly together to look at the skills value chain, to look forward, to see what we need to develop. Now, you know, I could put a wet finger in the air and say that, you know, some of those niche short courses that we're going to need for the future are going to revolve around digitalization, artificial intelligence, robotics, machine learning, probably about propulsion and eco-fuels, you know, those kind of things. And then the outcomes will be developing the syllabi for those particular core skills that are going to be needed in the future. So I think that's the, you know, yes, we know what we need now. Yes, we need, of course, need to develop and train for what we need now and in the near future, but we also need to look to the further future.
Thank you. Rob, would you say you need more classroom time, more learning of all of this stuff, or is it that on-the-job piece, and that's where you'll pick up those extra skills as technology develops and you need those new elements?
Yes. Judging because I chose the apprentice route, you guys probably would have guessed that I learn by doing things rather than learning out of a textbook, like let's say university or something like that. To answer the kind of burning question of how do we get more skills and things like that or more advanced skills into specifically apprentices, we also need to look at the non-apprentice workforce, because if your apprentices are here and your workforce is here, but you need them to be up here, your apprentice is only going to be to the same level as your current workforce. So you need to get the extra training into workforce, or to bring experts in who can then train the apprentices and any other professionals that are in the company. One thing that David touched on that I quite liked was how do you approach something that you don't know? So one thing that we learn as apprentices is not necessarily what we learn, but how do we learn, and how do we approach something that we don't know? More importantly, without breaking it or breaking us. If it's a new process or a new piece of equipment, and how do we chart our own progress forwards in both a way that we can learn, but also in a way that is safe and kind of constructive.
Excellent. So reverting back to the previous panel, there was a discussion on the shortage of robotic skills in the UK. And really my question is, where's the gap? Why haven't we got that? We've clearly got 3 very talented people in the room, yet we were hearing that there was a lot of hiring coming from internationals. So what's the gap? Is it that young people aren't interested in this type of work? Is it the lack of training available? Is it employer expectations or aptitude? Where's the gap? If I could perhaps throw that one to Kathy first.
Ooh. I think one of the things... Thanks, Joanna. Absolutely. Where do I start? I think we're lucky in space. There's no question we are lucky in the space sector. You know, we don't really have a problem getting people into us because it's cool. It's, you know, it is rocket science. And the other thing that inspires kids is dinosaurs, and they're dead. So let's just stick to space. So we can inspire people to come to us. That's good. We need more people coming in though. And we're not, you know, whilst I think I shared probably 20 job applications, I mean literally 20 job adverts this morning, which is, I've never known a time when there have been so many coming across my desk to share to the community. And those are, quite a lot of them say, must have 5 years experience. I slightly question whether they really need 5 years experience, or whether that could be better done by somebody who's earlier in their career. So we need more at the bottom. We also need to do a great deal more about retention, because there's a lot of evidence that we're losing people at around the 3 to 5 year mark, at the end of the graduate training program, not at the end, remember, of the apprenticeship programs. We need to do more about hanging on those people. And what can we do on a drip feed basis, on a regular basis, that everybody coming into the sector has access to short, bite-sized chunks of relevant training that will keep them up to speed with all those new things. If you work for a big company like Airbus or otherwise, you will find access to those bits of training. You'll be learning from your peers and experts higher up the chain. It's much harder if you're in an SME. Sometimes you can find those opportunities, you can Google it, and the training is there. Quite often, the training's invisible to most of us. And unless you know that somebody's offered it before, you can't even find it from that perspective. So we're also, subject to CSR, we're working on a concept where we can bring all of those opportunities together in one place. So everybody can see them, people can access them, and more importantly, the providers of that training can aggregate those needs of that diverse community out there who might need that training. So there's a lot of different strands there.
I'm going to jump around and then I'm going to ask everybody for questions in the audience, so get yourselves ready for it. So you just mentioned the word diversity. It's not too bad in this room today, but it's not exactly brilliant. How do we improve the diversity? If we look at Oxford Space Systems, I know that collectively your workforce speak over 30 languages. You work with a whole range of diverse people, which I guess you can probably tell us a little bit about how good that is and the benefits of that diversity piece.
So one of the key benefits of diversity is that you'll never have a boring lunch break. There's always something that somebody will have that they've done in some other country, or you say something and they'll say, what did you just say? Or, and not necessarily speaking the English language, but also just like figures of speech and different other pieces. So it's always great fun having people from loads of different nationalities and backgrounds in one room. It's quite a nice colourful place. But also you gain different ways that people think as well. And you got the more people, the more heads that you put on a problem, you get different angles that will allow you to kind of solve that. And then from an apprentice point of view, you've got all of these different people, and then you've got all of those people that you can also learn from as well, rather than just learning off one person. And then you're almost like a screen print of one technician. You're a screen print of everybody else, and then you sort of become your own person. So it's a great sort of like there's loads of different flavours to kind of draw from and sort of enrich us as apprentices, basically.
I couldn't have teed up that answer better if I tried. David, what's OAS doing to try and make sure that they've got a really diverse intake every year?
Slightly loaded question, but thank you. So, yes, CSR acronym comes up again. We just we realised a while ago that diversity in OAS was an issue. In fact, diversity is an issue in apprenticeships across the UK. If you look to why that might be, if you go right back to the roots of how an apprenticeship is designed, I think Edie and I, equality, diversity and inclusion aren't part of that process. They're very much an add-on. Sustainability is just becoming part of that process. I've had conversations with various people at the sort of managerial level of apprenticeships, and there's not a great connection and acceptance that this is an issue, but it will be. I'll remind them. Anyway, so an example: if you're somebody who is a wheelchair user, you can get into OAS because there's a requirement through building regulations that people can get in. But could you reach a bench? Could you use a milling machine? Could you use a lathe? Could you produce some of the pieces which are actually required under the apprenticeship to be produced? If you can't access the machines, you can't produce them. So therefore, you can't do the apprenticeship. You're not going to apply in the first place. So there's a fundamental work to be doing at that level. And what are we doing about it? So we bid to government last year for some money to try and look at different ways of doing this. So everyone does STEM engagement. They go into schools. They send middle-class white kids to middle-class white schools and get middle-class white apprentices. All that goes on, but it clearly is not working. There's something fundamentally wrong there. So we bid for £7 million to run a couple of pilots, one in Oxford, looking at how we can include diversity across the board, not just gender, not just race, you know, in terms of capability, disability, mental health, everything. Everything you can imagine. So there's one in Oxford, and then next year we're going to start one up in Coventry. And the reason we're doing two is because it's a different geographic and different demographic in Coventry. The output from this will hopefully be a report into Bays, which will tell them what works and what doesn't work. Because clearly whatever anyone's doing at the minute isn't working. Yeah, so the biggest challenge for us is not flipping back into what everyone else is doing and trying to stay different, stay fresh, innovate, and I think that's the most common conversation I have with think outside the box, do it differently, you know, that's not worked before, do it. So yeah, that's what we're doing, and we'll let you know how it goes. It's a very exciting thing to do. I think we had our first meeting of our subject matter experts from across the challenges and disabilities the other day, and I felt really enthused by that meeting, that I felt actually there's a chance this was really going to make a difference. So, yeah.
Oh, it's brilliant. I love it when there's something actually happening, tangible. It's going to change something. And as Kathy said, you know, young kids, they're passionate about dinosaurs and space, but we lose the diversity as we go up through the age group. So there's a lot of work going on there. I know, Kathy, you might just want to mention STEM ambassadors and 1 million interactions and things like that.
I think one of the things in space that we now have the evidence for is that the numbers who are coming into the space sector reflect the diversity of those going through the education system, coming up to do A-levels, going into universities. That's good, that's okay. But what Joanna has just highlighted is actually the fact that we've got to do more to encourage greater diversity of young people continuing their studies, keeping their options open with those subjects at school, still at school. And so you've mentioned STEM ambassadors. We kicked off an initiative in 2018 called 1 million interactions. Our objective behind that is for every single person in the space community signed up as a STEM ambassador or one of the routes to supporting schools through the Careers and Enterprise Company. So they have a scheme called Give an Hour, for example. People, you know, every one of your employees can fit that profile. You don't have to be a STEM person. You might not be a STEM ambassador, but you could be a very valuable person to go into schools to say, hey, I'm an accountant, I'm an HR person, I'm the executive assistant to the chief executive. It doesn't matter what you do. What matters is that you can spread your enthusiasm for the sector and tell these young people how they can develop themselves in all sorts of different ways and have a place in the sector. So please sign up to 1 million interactions, because the reality is no company here survives on STEM alone, and we all need all those other skills as well.
So that's given you the first challenge. Make sure that you are out there and reaching out to as many people as possible, as young as possible. The next,
can I put one little thing in?
Yeah.
We also recognise that not everyone needs to be in front of a classroom of kids, or even one kid. So choose wisely, and if it's not for you, we're not forcing you in that direction. Please recognise that.
But the second challenge, though, is any questions from the audience? Yep, one over there.
Hello, my name's Annie. I graduated from university in 2017. I think at the time when I went into university, apprenticeships wasn't really an option, or it wasn't an option that was presented to me. And I think what we're seeing now as well is, for me, I chose to go to university because there was this idea that as a graduate, you come out of uni and you are hired as an engineer, which typically, I don't know, again, if the culture is changing, but essentially you have a higher salary or you get into a job with potentially more opportunities. And I think coming through apprenticeships, people are hired, like you keep saying, as technicians. Personally, I think we're all engineers, and I think there's some value in maybe connecting the two, graduates and technicians. As I said, I think we're all this one pool. I think we've got this idea almost of sort of upstairs, downstairs. What do you think can be done by employees to sort of bridge that gap and, to get them working together as one utilised pool of engineering?
So I think you're absolutely right, and that is the basis of the Skills Factory proposal that I mentioned earlier. It's about bringing people in on 1, 2 and 4 year schemes. I don't care if they're apprentices or graduates or they've returners and they've had a bit of time out of work. They're all the same. They're all problem solving. They just need a little bit more time to get the qualification or accreditation. But I think you're absolutely right that we shouldn't be differentiating. What we really want, as I think somebody said earlier, is that willingness to go the extra mile, that mindset of actually wanting to achieve things. It's not all about the list of sort of qualifications they've got on their arm. It's that list of, it's that willingness to do things. Would anyone like to comment on that point about how we actually just get everybody together in this discussion?
Yeah, I've had a challenge over the years trying to work out. So they're both absolutely viable access paths to professional employment. Sorry, tripping over my own words. Professional employment. When do they come level? Obviously, if you're a graduate, you come out with a big bill. If you're, but probably stronger academically. If you're an apprentice, you're more hands-on. You learn by doing. Not saying that you haven't got sort of acumen for academic stuff as well, because most of our apprentices, or someone else can give you the numbers, go to do HNCs, HNDs, degrees as well. So they're just different ways of getting there. And I think after about 4 years of coming out, whichever training you did, you're about the same anyway, in terms of, and that is because you've been in this big washing machine of employment, working on projects together, working on challenges together, socialising, doing all that good stuff. So I think naturally people tend to mix, share experience and skills. So I think that sort of happens in the workplace anyway. But I applaud anyone that's going to force the issue into with the Skills Factory and trying to sort of engineer that outcome.
I was just going to say to Rob, I mean, you work in a diverse group of people. I know there are people with PhDs down to graduates, apprentices. But my sense is it's that diversity of thought. Some people who are good at the more hands-on and looking at it in different ways that has enabled Oxford Space Systems to grow so rapidly. Am I right?
Yes, you are. Yeah, I don't really know what the question is there, but yeah, I mean, when we have like something new, you get more PhDs thrown at it than apprentices. We're not told to make something completely brand new, but at the same time, our opinions and our ideas for how to make things better are also equally as valued. So we all have like something to give, even if it is just that 1%. At least we're adding something positive to that sort of experience and development.
Going back to the point earlier about robots, I'm not sure the Robs in the room could necessarily give that. Did you want to say something, Kathy?
Well, I think completely I agree. I work today with people who've come through all sorts of different strands, and it's about what you know and how you can deliver it and what you bring every day to the job. That's the important thing. Are you going to put your shoulder to the wheel with me? In which case, I don't care what colour you are or anything else. Let's just get on with it. But I think the other thought that was running through my mind, which I've now forgotten, of course, is that it's very important to bring those people together. And there are some companies, there are some organisations. I mean, I'll use ESA as an example. They are very adamant. They do not want anybody who doesn't have that effectively second degree. Okay. But I'd say they're probably losing out on something. And there are other companies that I know who favour those with that first or second degree and can't possibly train anybody lower down the tree. I think, I wonder how long that'll last.
Have we got one more quick question? Oh, at the back there.
Just to follow up on that point about the differentiation, if you want, between the sort of going up the technician route and the engineering route. Very quickly, I worked at British Aerospace as a graduate engineer. I was put in charge of the Ariane launch table, and I went out there to do a refurb. I didn't know the first thing about what I was looking at, but I had 30 technicians who blindfold could take it apart, put it back together as long as I told them to do it. And that was the distinction about being an engineer, that you're in charge, people look to you for leadership, but they don't necessarily need you to tell you what to do. And so there's a balancing of learning experience that goes both ways, from my experience. There's a humbleness for the engineer, and there's an authority that comes from the apprentice or the technician's point of view. But that talks to me about being multidisciplinary in many ways in a skill set. And maybe this is sort of asking David and Kathy about their views on that if you've got a design engineer, a development engineer, and a technician in the room, how do they work together as a team? Because that's not about their skills development, that's more about business culture. And does skills development step into business culture in order to make sure that what you're doing is going to be effective in the workplace?
Yeah, can I leap in on that one?
You can leap in very quickly.
Okay, co-location is the solution that we found at UKA. You put those people working on that project in the same room, so they're working together. You don't have the draftsman up in the drawing office and the engineers in one building and the techs in a workshop somewhere else. Put them all in the same team, get them working together, thinking together, laughing and crying together, and they work together very well and grow.
Having lots of laughs over lunchtime and things like that. But I think that really nicely tees us up over for the lunch break now, and an opportunity to go around all the exhibits, as I'm sure we're just about to hear. But I think, you know, this is a really key point. This is about a conversation. How do we make sure that people like Kathy, David, myself, that are all putting ideas into CSR, is the Comprehensive Spending Review. It's the big government review of money for anyone who missed that. It's how do we make sure that all of those are connected to the businesses that are actually using the people at the end. That challenge that was put out earlier, how do we make sure the educators have the right information to make sure that they're bringing those people through correctly? And I think that's really what we need to be talking about. How do we get that conversation? How do we cohere all of these different ideas? And how do we make sure that we're coordinated so that we can deliver? Because the last thing we want to do is in 5-10 years' time still be hearing that we can get the skills, but they're all not from the UK. There are clearly amazing people here in the UK, and let's make sure we're training more of them up. Thank you very much to our panel today. Thank you to Kathy, to David, to Rob. Thank you especially to Max and Cameron for their brilliant introduction to this panel, and look forward to talking to everybody over lunch. Thank you.
Okay, thank you ever so much, panel, and thank you to Joanna. That was an excellent session, so thank you. Just so I'm going to do a couple of things before we bring this session to an end. First of all, I'd just like to talk about a couple of events that we will be doing together in the new year. So we are now, yes, we are going into 2022, believe it or not. So the first one is we've just launched the National Manufacturing Summit in February, of next year. That will be across a number of sectors, and we will be bringing together, as we have done today, but in a larger event, both those people who are helping the adoption of manufacturing technologies, and also those who have got the stories behind it. The second event, and Kat is sat here at the front, and I know Mike Curtis-Rouse at SATAPS is involved in this, is the Made in Space event. Again, that's happening in March 22. We have in this building, and I know it's how successful it is the Satachino, which happens every month and is extremely well attended. I know that's been going on virtually and is now a here in-person event. But there's a question there in terms of what else would you like us to do? We've collaborated within this event, but there are loads of things that we would like to do, but we need you to tell us. So that's the event. The last thing, obviously, is the thank yous, and there are a lot of people that I do need to thank, so I am going to miss someone out, so really apologies. First of all of the contributors. Without them and without their insights and different viewpoints, this event wouldn't have been what it is. To the teams at the MTC, at SATAPS and Harwell, to the AV guys who make us look and sound much better than we really are, to the catering team, so we're just about to enjoy their delight, at SatApps, particularly to Manoir, to Tim and to Richard, at Harwell, particularly Catherine Page, who helped us coordinate from that point of view, and from the MTC, Connor, Jess and Sandy within our marketing team. Also, all of our engineers who have been are effectively on the road for the last 2 weeks. So they've been down to London, they come to here, and we've got the launch of our digital manufacturing accelerator up in Liverpool. So they are on the road, and thank you very much for that. They're all absolute stars. If I can say, there is one supernova, who is a guy who's helped me along the way, made me look much better than I really am, which is AJ. AJ has actually put a lot of the logistics together and brought everyone together. So I particularly like to thank him. He stood just by the door there trying to avoid my gaze. So if you'd like to thank him and give him a pat on the back as you go out. So as I say, this is, I hope, the first of many such joint events in the future. As Joanna said, you stole my last line, but I don't really mind. It is a start of a conversation. So please continue over lunch and do make sure that you're looking around the demonstrators. So thank you very much, and a safe journey home in this horrible weather. So thank you.